Hey everyone, welcome back. From this module, we are going to start Docker, and this is the first class of Docker. In this class, we'll cover what is Docker and why we need it. Then we'll see container with virtual machines. After that, we'll cover core Docker concepts like Docker file, Docker image, Docker container, Docker hub, etc. Then we'll install Docker in our local machine. After that, we'll learn about some commands which we will use in our daily life as a developer. So let's start with the problems. Which problems we are facing without Docker. So imagine this. You build a Java microservice on your machine. Everything works perfectly. You send it to your teammate. They run it, but it crashes. And then you say, but bro, it works on my machine. Now, every developer has said this at least once. So the question is, why does this happen? In your machine, it's working fine, but in your teammate's machine, it crashes. Why does this happen? And more importantly, how do we fix it forever? If it works on your machine, then it should work in your teammate's machine as well. Okay, so how do we fix that it forever? So that's exactly where Docker comes in, guys. Let's understand this properly. So first, what is Docker? In simple words, Docker is a tool that lets you package your applications along with everything it needs, like Java, configurations, dependencies, etc., into one single unit. Okay? And that unit is called a Docker container. Now the magic is happened. This container will run the same way on your laptop, on your teammate's laptop, or even production server as well. No surprise, no error. That is the Docker. Now let's understand the real life analogy. Think about shipping containers in real life. You can see the image of left side and right side. Before containers existed, every item has different shape. Loading shape was chaos. Then came standard containers. You can see that in left side. Same size, easy to stack, works everywhere. Docker does the same things for software. It standardizes how apps are packaged and run. Okay, so now let's understand container with virtual machines. Now you might be thinking, is this same as a virtual machines? The good question. Let's break it down. Virtual machine is like renting a full house, and container is like renting just one room. You still share the building, but your room is fully isolated. Now key difference is your virtual machine is heavy, and since you are virtual machine means you are renting a full house, so it's heavy. And container means you renting a single room, just one room. So that's why container is lightweight. And since virtual machine is heavy, speed is slow of the virtual machine, and container speed is fast. So in real world system, we prefer the containers. Now let's understand the core concepts. Very important. Okay, so don't skip this. First, we have image. Image is like a blueprint. if you are from the Java, think of it like a class, Java class. Okay, it defines what your app looks like. Then we have container. Container is simple. It's a running instance of an image, just like object from a Java class. So image equal to, you can say, Java class, and container equal to object inside that Java class. Now we have Docker file. This is where things get interesting. Docker file is just a text file where you write instructions to build your image. We'll go deep into this in next class. Now let's say the Docker Hub. Think of Docker Hub like a GitHub, but for Docker images. You can download images, share your own images into Docker Hub by creating your account. Okay. Then we have Docker Engine and daemons. So behind the scene, Docker Engine is the core system. Docker daemon is the brain running in background. And when you type commands, CLI will talk to the daemon. Okay, now it's time to install Docker in our machine. So guys, if you are using Windows or Mac, you will use Docker Desktop, and if you are in Linux system, you will install it in manually. So for installing Docker Desktop, you can just search Docker. Go to the Docker's official website. Let's visit it. And here you can see the option for download Docker Desktop. Okay, when you click on download, you will have different options like for Linux, Windows, then Mac, etc. So if you are on the Windows machine, you can click on Windows, and you will directly able to download the Docker Desktop installer. It's a simple step. Okay, so yeah, download Docker Desktop, install, then come back to the class. Let's go to the slide again. Once you finish the installation part of Docker, it's very important to verify it. Okay, so how you can verify that Docker is completely installed in your machine or not? Open command prompt, and you can type command docker -- version. Docker -- version. If Docker is successfully installed in your machine, it will give you the Docker version which is installed in your local machine. Then you can run hello world image in your Docker. So for that, we need to open our Docker Desktop. Once you install the Docker Desktop, you can open that Docker Desktop. Okay, so let's wait. It will take a couple of seconds to open Docker Desktop, and you can see it's starting the Docker engine. When you open Docker Desktop, it will automatically start your Docker engine. And here in the left side bottom, you will see engine is running. Okay, and when you click on the pause, your Docker engine will be paused, and by clicking on the resume button, you can resume your Docker engine. Okay, great. Now let's go to again CLI command prompt, and you can run hello world image. So Docker command is for running hello world is a Docker run hello world. Hello world. Okay, when you type Docker run hello world, it will First guys, it will check if hello world image is present in your local machine or not. If it is not, then it will pull it from the Docker hub. So let me hit the enter and you can see it's unable to find images. That means hello world image is not present in my local machine. So it has pulled the images. Okay, once the pull is completed, download part is completed, it will run this image as a container, and you will be able to see this message like hello from Docker. This message shows that your installations appears to be working correctly. If you're getting this kind of message, that means you are ready to use Docker in your local machine. Okay, now inside the containers, you will be able to see this hello world container. All right. Now guys, let's go to the CLI again and let me maximize it. Now, if you want to download any images from the Docker hub, you can run command docker pull nginx. Nginx means image name. So let me show you the Docker hub as well. You can search for Docker hub. Docker hub is similar to GitHub. On GitHub, you are pushing your code, and on Docker hub, you can push your images of Docker images. Okay, so this is the Docker hub. You can log in or sign up and directly search for images. So let me search for nginx. Okay, if we have nginx, then mysql command mysql. So you can see the mysql different images. Okay, now let's go to the command line, and first let's pull the image from Docker hub nginx. Docker pull nginx. Let me show you this nginx again. Nginx. Now guys, if you don't know about the nginx, don't worry about. You can read the simple description about this and what it does. This image are published with the zero non etc. Okay, so we are using this nginx for testing that pool is working, then Docker image is downloading or not, then it is running in our container or not. So for that we are using this nginx images for now. You don't need to know what is nginx and what it does. Okay, so let's pull the image docker pull nginx, and it will take couple of seconds to download from the Docker hub. So let's wait. Now image is downloaded. How you can check? Either you can go to Docker desktop, go to images, and here you will be able to see all the images which are present in your local machine. And here we have nginx, which we have currently downloaded, and hello world as well. Okay, and these are the old images which are already present in my local machine. Now guys, you can check in CLI as well. How you can check? So we have command docker images. Docker images. But one thing to keep in your mind is when you run any command related to Docker, your Docker engine should run. Okay, if your Docker engine is in a running state, only then Docker command will work. If you close this Docker desktop, Docker engine will stop automatically, and then your Docker command will not work. Any Docker command. Okay, so let's now run this Docker images, and you will be able to see all the images which are present in your local machine. Now let me show you the where is our nginx. Here you can see we have nginx. If you remove this, if you want to remove this Docker image, you can run command docker rmi nginx. Okay, either you can use this command or either you can delete from here as well. Checkbox it and delete, and here also you will be able to see the delete button. Okay, so I will not remove this, but if you want to remove, you can use that command. Okay, because if I will remove this, then I will to download it again. Okay, so let me not remove it. Now if you want to start a container, you can check all the running containers inside it. Let me remove this hello world now. I don't need this. Okay, these are the existing container, and let's keep this. Okay, let me remove this docker compose as well. I have removed this. Okay, currently I don't have any container, but if you want to run any container on any images, just run command docker run nginx. Okay, so it will create new container for this image nginx and run it. Let's run it. Okay, and you can see the logs here. And now if you want to run container in detach mode, what is the detach mode? So if you want to run container in background, if you don't want to see any kind of logs, and if you want your command prompt to be free, then you can run this in detach mode. Okay, in detach mode you will be not able to see any kind of logs. Container will run but in the background, and your terminal will be free. So let's do one thing. Okay, I'm exit from the container, and now let's go to the desktop, and here you can see we have the container. Let me remove it once, delete. Now let's go to the command prompt, and let's run this container this time in detach mode -d. Okay, and this time guys you will be able to see only the id of the container. That means if you are getting this kind of id, that means your container is started, and this is the id of your container. Using this id you can access your container. Okay, now you can see name will be provided by the docker. If you will not provide any kind of name in the command, then automatically it will provide a default name. Okay, now what if you want to provide your own name? Okay, if you don't want this default generated name, you can provide your own name as well. So how you can do that? Docker run, then -d means in detach mode --name, and you can provide the name as well. Like let me provide here Josh nginx, Josh nginx, and then you need to provide the image name nginx, and let's hit the enter. Again new container is created with the name Josh nginx. So let's check that. Here you can see Josh nginx. Now you can map the port as well. Currently you will be able to see ports empty. Okay, but if you want to access this container, how you can access without exposing the port? So port mapping is very important guys. Now how you can map the port? Let me clear once. Okay, clear and clean command is not working. So let me do one thing. minimize it and expand. Okay. Now let's run the docker command and map pod as well. So docker run -d in detach mode and hyphen name. Let me provide the name as well. So Josh NGINX with port. This is the docker container name port, and let me provide map the port. So for mapping port we have hyphen p means port 8080 colon 80. Okay, and then we need to provide the image name nginx. Okay, by using 8080 guys, this is the expose port. Okay, by using this port you can access container, and this is for internal docker. Okay, now let me run this, and you can see again a new docker container is started, and here you can see the port as well, docker nginx with port. Okay, great. Now in command line also guys, you can check the containers. So if you want to check running container, just search for just run command docker ps. It will give you the running containers, running containers. These 3 containers are currently running in my machine. Now if you want to see all the containers including stopped, then you need to give docker ps hyphen a. Hyphen a means all the containers including stopped as well. Okay, now currently you can see 3 container is running, and let me stop any container. Let me stop first one. Okay, container is exist. I didn't delete the container, but it's stopped. And now let's go to the command line. If we check docker ps, so currently we have only 2 container, but if we run docker ps hyphen a, then we have 3 container. Okay, these are in running state. Sorry, two containers are in running state, and one is stopped. This is existed. Here you can see the status. This status is up. Okay, means this 2 container is running. Up means, and this existed means it's not running currently. Okay, now it's time to see docker in action. So guys, our container, this Josh nginx with the ports is running on 8080. Now we can access this in our browser. So let's go to the browser and run here 8080, and there you go. You can see welcome to nginx. If you see this page, nginx is successfully installed and working. Okay, you can see our container is live. Now this is the one demo. Now let's see the second demo. So currently our nginx container is running. Let me stop both the container, this one as well and this one as well. Okay, now guys, in second demo we'll pull the MySQL image. Okay, and inside docker we'll run MySQL. We don't need to download it manually. With the help of docker desktop, we can use it. So guys, if I can show you my SQL command line, okay, currently my SQL install in my system, okay, separately. Let me close this. So there is many steps to install MySQL, guys. You can go to the MySQL command, MySQL website. Okay, I'll not say that it is complicated, but it is a little bit difficult in compared to Docker. You need to follow the steps, okay, then set password, etc. But with the Docker, let's go to the Docker hub. Where is Docker hub? Let me search for MySQL image. Go to the image. Okay, MySQL working on most popular source database. Image version is this. Okay, so guys, with the Docker you can run MySQL, run or download MySQL in your machine with just one command. Okay, so let's download MySQL with the help of in the Docker and run MySQL as a Docker container. So let's open the terminal and we have command, guys, Docker run in detach mode, means -d, and I want to provide the container name. So hyphen name. Let me give here a Josh MySQL DB. MySQL DB. This is the container name. Then we need to provide the environment variable, MySQL password and MySQL database. Because guys, if you want to use this in your Java project, you need the MySQL password and MySQL database name. So that password and database name we need to expose from here. Okay, only then you can use it in your Java project or Spring Boot project. So let me provide here MySQL. MySQL root password. Okay, password equal to, let me give here root. Then let's provide the database name, MySQL database equal to MyDB. Okay, then let's provide the port. So 300 port is 300 3306 3306. Okay, here we have 333. Let me remove one. So guys, as I told you, currently in my system, look, MySQL is installed. That MySQL by default running on 3006. So I need to give different port because 3006 is already allocated to my local machines MySQL. So let me give here different port. Now with this, with the help of this port, this password and MySQL DB database name, you can use this MySQL in your project. So now guys, let me show you the MySQL project as a Java full stack Spring Boot project, how you can use that. So let me open one project. Okay, let me open our okay, let me open one project for now. Any project. Okay, new window, and you can see inside the IntelliJ I have opened the airline microservices. Now let me go inside any microservices, like we have booking service. So let's go to application.yaml file, and guys, you can see database. Inside the database configuration, what things we need? We need the port, then username and password. So here we have username is root, password is root, database name is mydb, and this is the port. Okay, using that you can now use this in your any Spring Boot project. Now what I'm gonna do is I will hit the enter and start the container. Actually, one more thing is missed here. I need to provide the image name. So I want to run MySQL 8. Now guys, you can use any version. Okay, I'm using here MySQL 8. If you want to use MySQL 9, you can use that 9, 9.6, etc. 8.4. But I'm using here MySQL 8. Okay, just hit the enter. First guys, it will pull the image from Docker Hub because it is unable to find the image locally. So it will pull it from the Docker Hub, then it will start the container. So it will take some time. Let's wait a couple of seconds and give it time to finish it. Download completed, digest, status, download a newer image, and we got this ID of Docker container. Now if I run here Docker ps, you can see this MySQL container is running. Josh MySQL DB container name is. Okay, now guys, let's enter inside this container. Okay, how you can enter inside this container? Docker exec, using docker exec command it, and now you need to provide your Docker container name. So what is the container name? Josh MySQL DB. MySQL DB. You can see the name of our container, and bash. Now let's hit the enter, and boom guys, you are inside the container. Now now let's get into the MySQL client. So how you can get inside the MySQL client? MySQL, then we need to provide -u, means username is root, then -p means password. This is also root, and let's hit the enter. So it's asking for password again, so let's provide root. Okay, it says access denied, localhost using password. Yes, so I think I have provide the wrong password, so let me try to get inside it again. -u root -p. Oh, command not found. MySQL. Okay, now let's provide the correct password. So that is nothing but root. Okay, now I'm inside the MySQL client. So that's it guys. Now you can create a new table, new database. So let's do one thing first. Create new database, or you can show databases as well. Okay, currently this default databases we have. Now let me create new database. Let me create database, and database name is JoshDB. Okay, let's hit the enter, and you can see a query. Okay, one object means database is created. We can verify by running show databases. Okay, you can see the JoshDB. Now when I click control, when I type control C, okay, and or control D, with the control D I will get out from the MySQL client. Now I'm inside the Docker container, and if I press control D one more time, I will exit from the container as well. Okay, so this two example is enough guys. Now let's go to the our slide and understand the. Okay, so we have checked this in our browser, and this is the Docker architecture we have. See, like a Docker client, will give command to the CLI, then CLI will talk to the Docker daemon, and it will manage the container and images. If needed, pulls images from the Docker hub and start the Docker container. So that's the architecture. And finally guys, let's see the key takeaways. So let's quickly revise this. Docker packages everything together. Okay. Second point is containers are lightweight and fast compared to virtual machines. Third point is image equal to blueprint. You can imagine image as a blueprint, and a container equal to running app. Next point is Docker makes app portable. Okay, now that's it for this class guys. In the next class we'll build our own Docker image. Currently you can see we have pulled the images from, we have pulled all the images from the Docker hub, like MySQL image, then nginx image, etc. But in the next class we'll build our own Docker images, okay, using Docker file. Also we'll explore the Google Jeep, this very powerful tool to build Docker image without Docker file. And now guys, your homework is run PostgreSQL container in your local machine, get inside the Docker container, okay, then as we have created database inside the MySQL, your task is to create a database in PostgreSQL, create tables, etc. Okay, so do this by yourself, don't just watch. Alright, so now let's meet in the next video guys. Guys, in the last class we were using ready-made images from Docker hub. We just did Docker run nginx and things worked. But now think about this, our Josh Airline microservice are custom. No one uploaded them for us. So question is, how do we convert our own code into Docker images? Today I will show you two powerful ways. to create Docker images. So first way is to create a Docker file manually. Okay, in this you will get full control and in this standard approach. Then you will be able to convert them into Docker image. Then second approach is use Google Zip. Super smart way for Java developers. And honestly guys, after today, you will never struggle with Docker builds again. So let's understand what is a Docker file. Very simple. It's just a text file where you write step-by-step instructions to build your Docker image. Docker reads it from top to bottom and builds your image layer by layer. Each instructions create a layer and Docker is smart. It caches layers, so if nothing changes, it won't rebuild everything again. Now, let's understand the Docker file instructions. Guys, don't try to memorize this. Just understand the purpose of each instructions. First, we have from. Every Docker file start with from. This is your base image. Okay, from OpenJDK 21 Slim. Like it's saying start from Java 21 environment. Instead of this OpenJDK, you can use another image as well, which are providing Java installed. So we have another image is Eclipse Temurin 21 JRE. So it is a production standard. We'll use that image to write our Docker file. Now let's see the second instructions is working directory. So guys, this sets your working folder inside the container. Working directory app. Then we have copy. This copies file from your system into container. Okay, like your system code inside this and it will copy that code into the container. Then we have add. So add is like copy but with extra features like downloading file, etc. And in real projects we mostly use copy, not add. Then we have run instructions as well. This will runs the commands during build. Okay, not when container runs, but only during the image build time. Then we have environment. So environment used to set environment variable like settings, Spring profile to prod, dev, etc. Okay, if you have a MySQL password, database name, etc. Those are the environment variable. Now we have expose. So this tells which port your app uses. Okay, it doesn't actually open the port, but it will tells which port your app will be used. Then we have CMD. This decide what runs when container start. Okay, so CMD default command can be overridden. And then we have entry point. So it's a fixed command. It's hard to override. Now, if you are confused guys, just use entry point for Spring Boot. Okay, no need to use CMD. Then we have args. These are build time variable, only used while building image. Then we have volume. This is for persistent data. so your data doesn't disappear when container stops. Then we have label. It's just like a metadata, like version, author, etc. So we have label maintainer. Here you can provide your email ID josh@email.com. Then you can provide the version like 1.0, 2.0, etc. Okay. So that's enough for the instructions. Now it's time to build real Docker file. So first let's do one thing. Go to Spring Initializer, create one demo project. Okay, let me give here com.josh. We'll create the demo Spring Boot project and containerize it. And let me give artifact ID Docker demo. Okay, let's give it name Docker demo. Packaging will be there. Configuration YAML. 17. Let me add Spring Web and DevTool. Spring Boot DevTool. Only these two configuration. Now let's generate the project and Docker demo. Let me save this project. Navigate to the project. Unzip this. Extract all. Okay, now let's open this with IntelliJ IDEA. Okay, it's opened. Now let's open the src inside com.josh. Let me create one class, home controller. Okay, let me rename it. Now let's annotate with the REST controller and create one public method. It will return a string. Method name is home controller. Let's return here. And let's provide the message. Hey, I am demo Docker project. Okay, and let me annotate this with get mapping. That's great. Now let's start this project and it will run on port 8080. So inside the console, you can see Tomcat 8 started on port 8080. Now let's go to the browser and check this 8080. Okay, hey, I'm demo Docker project. So currently, guys, it's running in our local system. But now we'll containerize it and run it as a Docker container. So first, guys, we need to build the jar file for it. Okay, so let's open the terminal and you can see I'm in the Docker demo project, or means in the root path of the project. So now to build jar file, I will run maven clean package, and let's hit the enter. It will take couple of second and create jar file inside the target directory. So let's wait till it, and there you go, it's finished. Our jar file is created. And what is the jar file name? So jar file name is this docker demo 001 snapshot.jar. So this is our jar file name, and you can check that jar file inside target folder. See, docker demo 001 snapshot.jar. Okay, it's ready. Now let's create the docker file. So I will create a new file file and give it name docker file without any extensions. Now inside this, let's start to build it. So for now guys, if you want to write any command, you can write it by hashtag. Okay, so this is our jar file we'll use. Now let's start with the from instructions. I told you before, from now here I will provide the image name, base image in which our Java is installed. So Eclipse Temurin and 21 version is JRE. From Eclipse Temurin 21 JRE. Now we need to set the working directory. So let's set the work directory dir. Working directory is nothing but work dir. Okay, then working directory is /app. Then we need to copy. Okay, copy our system code into the container. So here guys, we'll provide our target file. So sorry, jar file, where our jar file is located. So inside the target, we have this docker demo 001 snapshot.jar. So this is the path of our jar file. Okay, target, then demo, docker demo 001 snapshot.jar. Now from this path, we need to copy the code into container. In container, it will create app.jar file and copy code inside that jar file. Then we need to expose the port 8080. Then entry point. Okay, we need to provide the entry point. Java -jar app.jar. Okay, this is the entry point app.jar which we have created here. Okay, great. This is the most basic production setup guys of our Docker file. Now we can create image from this Docker file. So for that, open the terminal. Let me clear. Open the terminal in your root project of root where your Docker file is located. So my Docker file is, okay, currently I have created inside this. So I need to move out this Docker file from this package to root, project root. So let me move inside the project root. And where is the Docker file? Where it's moved? Yeah, there you go. Here we have the Docker file. It is located inside the our root directory, Docker demo. Okay, now from the Docker demo directory, we need to run command docker build -t, and then we need to provide the image name. So let's provide image name docker demo. And then you can provide the tag that is nothing but version of your project. So let me provide here for now 1.0. And last I need to provide a dot. So dot is nothing but where currently my Docker file is located. Okay, so path of that Docker file. So my current Docker file is located in a root file, so that's why I have provided here dot. Now let's hit the enter, and guys, it will take time to build Docker image. Okay, and there you go, Docker image is built. Okay, now we can check this is present in our Docker desktop or not. So let's verify, is this image created? Docker demo. So here you can see, guys, we have Docker demo. It's created 21 seconds ago, and version is this. Okay, now I can start the container of this image. So how you can do that? Docker run -d -p, and let's expose port, this time 5005. Okay, and internal port, let me keep 8080. Now hyphen name, so we need to provide the name of container. Let's give Docker demo project, Docker demo project. Okay, and now we need to provide the image. So image name is Docker demo and tag 10. Okay, now guys, let me stop this server, go to the browser. Okay, earlier it was running on 8080, but I have stopped the server, so now it's give this site can't be reached. Now let me run here 5005, because guys, our container will run on localhost 5000. It will also giving us this site can't be reached, because still we haven't started the Docker container. So now let's hit the enter, and there you go, guys. We have the Docker container ID, and container is created and it's running. Let's go to Docker desktop and verify that. Go to the containers, and here you can see Docker demo project. It started, guys. Okay, Tomcat started on port 8080. So guys, we have given the internal port 8080, but it will expose the port 5000. Here you can see it will internally it will start on 8080, but it will expose 5000, means we can access this container on 5000. So let's go to the browser, and there you go, guys. Hey, I am demo Docker project. See, now we don't need to run the project in our local system. It's running on Docker container, and it's working perfectly fine, guys. Okay, so that's much easy to create a new Docker file and convert and create the container for it. Okay, now guys, instead of writing manual Docker file, we have another option, that is nothing but Google Zip. Now let's understand what is Google Zip. So guys, this Google Zip is my favorite part, because here we don't need to write Docker file manually. So first let's go to the browser and search for Google Zip. Okay, go to this GitHub repository. This is the Google Zip. You can read this about the Google Zip, like Zip builds optimized Docker and OCI images for your Java application without Docker daemons. Docker daemon. Okay, so now guys, first let me explain in short what is Jib. So Jib is a tool by Google, especially for Java developer. Key idea is you can build Docker images without Docker file, without Docker daemon. Yes, guys, seriously, you don't need to write a Docker file manually, and you don't need even Docker daemon as well, means this Docker engine as well. You can directly create Docker image and directly push into your uh, Docker Hub account. You can do that by with the help of Google Chip. Okay, so now let me go to the slide and explain Docker Jeep. Where is that slice? Sorry, slide. Configure. Yeah, Docker Jib, Docker file with Jib. So guys, inside Docker file, you will get full control, but Jib is automatic. Yeah. Then when you write a Docker file and want to create image from this, you need Docker. But with the Jib, you don't need Docker install in your local machine. You directly create the Docker image and push to directly into the Docker Hub. And if we talk about optimization, where is the, I'm not able to. Okay, so let's go to the Docker. And guys, for optimization, we need to write optimization logic inside the Docker file manually, but in zip file, it's built in. And if we talk about the speed, so it depends on Docker file, but when we use zip, it's faster, much faster. Now let me tell you why Jib is powerful. So guys, Jib is smart. It split your app into layers automatically, dependency, resource, classes. So when you change code, only small part rebuilds. And we need to add a plugin if you want to use a Jib file. And where is this plugin? So let me find the plugin. Let's click on quick start. And there you go. This plugin you need to add in your project. Nothing complicated, just simple. After adding this in your project, you can run command like maven jib docker build and maven jib build. So maven jib docker build will build image to your local Docker daemon, and maven jib build will build image and push it to the registry, means Docker Hub directly. So let's do one thing, copy this plugin. Okay, let's go to our project. Go to the pom.xml file. Inside the plugins, let me add the plugin. com.google cloud tools jib maven plugin. This is the version and image. Here I will give the image name. So let me give a Docker demo, and then let me give 1.0. This is the tag. Also, guys, if you want to directly push into the Docker Hub, you need to provide your Docker Hub username, account username. So let me go to the browser, open the Docker Hub, and let me check my username. What is my username? Actually, I forgot. I didn't remember. So let me continue with Google, with code with Josh email, and there you go. I'm logged in, and let's go to my profile. So Josh. Okay, I can use this Josh as a my username. So let's go to the my project and provide here Josh. This is the Docker Hub username, then slash your image name you want to create and version of the image. Now let's load Maven changes, and let's do one thing. Go to again here. Currently you can see, guys, these are my images, and what it says, this image is about 1 year old and maybe outdated, consider archiving, inactive. Is there any way to remove it? Because I want to remove all of this at 1. Okay, let's do one thing. Let's keep all this as it is, and okay, guys, let me allow me couple of seconds. Give me some time. I will remove all this and come back. Okay, guys, I have deleted all the repositories. You can see inside the repositories I don't have any repository now. Now let's go to the project, and this is my image name. Now let's open the terminal. Okay, so guys, first let's try to build and publish it to direct registry. So let's run here maven zip and build. Guys, this will run this will work only when your credential is true. What it means. So if you have provided your correct username here, only then it will work. Okay, so in image, first provide your username, then slash, and this image name you can provide anything here, and tag also you can provide anything, but this is should be the exact your Docker Hub account username. Okay, now let's hit the enter, and it will take couple of seconds. Let's wait till that. Okay, I got this error registry 1 docker.io are still set up correctly. Build image failed. Okay, guys, so it says unauthorized. So let me go to Docker desktop, and currently I'm logged in with Josh Low, and my Docker Hub username is Josh, right? So let's do one thing, log out for now from this, and I will log in again. Okay, I'm signed out. Now let me sign in again. Let's from where? Yeah, here. Let's click on the sign in and continue with the Google. Okay, so let me sign in with the same account, and it's processed. Let's open. Now here you can see my username is Josh. Okay, so guys, make sure your Docker Hub account and your Docker desktop account are same. Okay, so you need to logged in with the same account in your Docker Hub and Docker desktop as well. Now let's go to the IntelliJ IDEA's terminal and run this command again, maven zip build, and let's wait a couple of seconds. I hope this time will not get any unauthorized error, and it will post our image to Docker Hub. So it's 42% completed, 46%. It is taking time, 78%. Let's wait, 83%, and build success, guys. Now let's go to the Docker Hub. Where is our Docker Hub? Yeah, repository. Now let me refresh this, and we're able to see one images. See, Josh Docker demo. Great, guys. So now this time we won't write any Docker file. What we do is just let me remove this. What we do is just provide this plugin inside the project, inside pom.xml of our project, and just provide the image name and simply run one command, maven zip and :build. So it has create image and push to the our Docker Hub automatically. Okay, now if you want to create it locally, you have another command, maven zip Docker build. So guys, it will create image locally. Okay, it won't post to your Docker Hub, but it will create the image locally. So when you run maven zip Docker build, so let's hit this endpoint as well, and let's wait to create it in our local desktop. So currently we have a Docker demo, but our image name should be Josh Docker demo, and it's finished. Now let's go to Docker desktop. Let me check if we got this image. Yeah, there you go, Josh Docker demo. Now we can run this. Okay, so we have Docker run -d in detach mode, and port is this. Name, instead of Docker project 1 this time, let's provide Docker zip. Okay, and image name also, guys, we'll use this Josh. Let me copy. And paste it over here, Josh Docker demo 1.0. Let's hit the enter, and okay, port is already allocated. So let me stop the running container for now. Let me stop it. Okay, and let's start this container again, Docker zip. Okay, it's created, but it won't running because port is already allocated. Let's do one thing. Let me delete it and run it from here. Okay, so you can see ID is generated. Now let's go to Docker desktop, and yeah, it's running. Now let's go to the browser and refresh this. Okay, you can see, guys, hey, I'm a demo Docker project. This is coming from the Docker zip image container. Okay, this Docker zip container. Great. So it's working perfectly fine, guys. Now that's it for this video. In the next class, guys, in the next class, we'll understand the Docker Compose file. Okay, how you can write the Docker Compose file for all our microservices, and how you can run Docker Compose file with with just one command, and all your services will be running. Okay, so guys, your let me give you the homework. So your today's homework is write Docker file for another service, like in our microservice project. You already know that we have many microservices. Okay, so write a Docker file for each of them. Then try Google Jib. Okay, then compare your manual Docker files, Docker image size, and image which are generated by the Google Jib. You will able to see the big difference in the size as well. Okay, so yeah guys, now that's it for this video. Let's meet in the next video. Hey everyone, welcome back. In this video, we'll create Docker image for all our microservices with the help of Google Jib. So let's go to the browser and search for Google Jib. And let me open this GitHub repository of Google Jib. Here we have the quick start. So let me click on that. And let's copy this plugin. Now go to IntelliJ IDEA and our microservices project. First, let's start with the ancillary core service. So inside pom.xml of the ancillary core service, I will provide that plugin inside plugins block. Okay, and now let me provide the image name. So image name, first I will provide the my Docker Hub username / now image name. So image name of airline core service is GDS airline. Let's start with the YouTube GDS airline. And let me give tag here. So that is nothing but version. This is the Docker Hub username. This is the image name, and this is the tag YouTube GDS airline. Okay, now let's open the terminal. Go to this airline microservice directory. So for that I will use cd. Then inside this we have services, and inside services we have airline core service, airline core service. Okay, now I'm inside into the airline core service directory. From here I can run command docker jib docker build. So it will build the Docker image. First let me load Maven changes, because we have make changes inside the pom.xml file. Okay, and make sure guys you are running this docker jib docker build command where your pom.xml file is existed. Okay, so make sure you are into the same directory where your pom.xml file is exist. Now let's hit the enter, and it says docker jib docker build unknown command. Okay. Okay. So let's check the correct command for it. Now let's go to the repository and scroll down here, guys. You can see we have command for maven compile zip docker build. Instead of docker, we have maven compile. Okay, so let me copy this command and use this, and let's hit the enter. And guys, it will take couple of seconds to build a docker image for our airline microservice. So let's wait till that, and you can see it has given the error. Okay, guys. So problem is it says it's not able to find the airline status, airline response, then airline request, etc. classes, because these classes are lives inside the common library, and we are using the multi-module project for our microservices. So what we need to do is first we need to run maven clean install from the root project wherever root parent pom.xml is exist. So let's open the terminal, and this is our root directory where our parent root pom.xml file is exist. Okay, so from this directory we'll run maven clean install. So it will install the common library dependency in all the microservices. Okay, so let's wait. It will take couple of seconds. Okay, and let's wait till it finished and give it some time. It's installing. Okay, processing. All right, test. Okay, so when you guys do it from the root parent, it will install common library dependency in all the microservices. You don't need to do it manually for each services. Okay, so let's wait. See, now it's creating for airline core service. Then now it's doing for the flight operation service. You can see here. Now it's doing for the pricing service. Okay. Then it's doing for a seat service. Now ancillary service. Now it's doing for the booking service. Okay, and guys, if you want, you can skip this part. Okay, now it's doing for the payment service. And it got success. Okay, now let's go back to the airline core service directory. Now let me run maven compile zip docker build command again, and let's see this time it is able to generate a docker image successfully without giving any error or not. So this time it's processing, and 93%, 4, 5, 6, 7, 8, 9, and 100%. And build is success. Okay, now let's go to the Docker desktop and check this image is got created or not. So guys, here you can see image is created, Josh YouTube JDS airline. That's great. Now let me minimize this and remove this. Now let me copy this plugin. So guys, we have successfully generated the Docker image for airline core service. Now I'll do the same thing for ancillary service. So let me go inside the ancillary pom.xml, go to the plugins. Okay, and here let me provide the image name. So I will provide here GDS airline service. GDS, let me remove this airline. Instead of airline, I will give here ancillary now, this time. Ancillary. Okay. Josh YouTube GDS ancillary. Great. Now let's load the Maven changes. It's done. Now let me open the terminal. Go to one directory back, then get inside ancillary service. Ancillary service. Okay, now you can see I'm inside the ancillary service, and I need to run maven compile zip docker build. So let's run this command and it will generate image for ancillary service. 30%, 32%, 81, 83, 84, 86, 87, 89, 91, 2, 3, 4, 5, 6, 7, 8, 9, and 100% build success. Let's verify by checking inside the Docker desktop. You can see now we have Josh YouTube JDS ancillary as well. So now let me close this, minimize this. After the ancillary, let's get into the booking service pom.xml. Scroll down inside the plugins. Let me provide the plugin, and let's provide the image name booking. GDS booking. Okay, let's load Maven changes. Open terminal again. Now let's get into the booking service directory. So go one directory back. Then get inside the booking service. Now from here we can run maven compile zip docker build. Okay, and let's wait a couple of seconds. 21% is done. 26, 30, 32%, 33, 82, 83, 4, 5, and 90. Now 91, 93, 4, 5, 6, 7, and 100% build success. Now let's check for booking Docker image. So you can see now we have Josh YouTube GDS booking. So let's go to the IntelliJ IDEA again. Let me minimize this, close this. Now let's generate image for flight operation service. Okay, so let's open the pom.xml file of flight operation service. Scroll down inside plugins. Let me add the plugin. Change the image name from GDS airline to, will provide GDS flight. GDS flight. Okay, let's load the Maven changes and open terminal. Now let's go to the flight operation service directory. So cd, first I need to get one directory back. Then let's get into flight operation service. Okay, now I'm inside the flight operation service directory. From here I can run maven compile zip docker build. Okay, now you can see 33% is done, 81%, 82%, 84%, 86%, and 90%, 91%. And it's 100% done now. Build success. Now from this, okay, let's verify because we already have run this command. Let's verify GDS flight. Okay, it's created. Now let me close this pom.xml, minimize it. Now let's go inside the location service. Let's open the pom.xml file. Inside plugin, let's provide this plugin Google Jib and change the name. So this is for location. So let me provide here location instead of airline. Location. Okay, let's load maven changes. It's done. Now let's open the terminal. Now let's get into the location service directory. Let's go one directory back, then location service. Okay, and now from this location service directory, let me run this command maven compile zip docker build. And it will take couple of seconds. Let me do one thing till that. Go to the payment service pom.xml file and let's scroll down, give the plugin and change the name. Instead of GDS airline, I will give here GDS payment. Okay, now let's load maven changes and let me check the terminal. You can see build success for the location service. So first let's verify inside the docker desktop that the location image is got generated. This location service images get generated. Let me minimize this. Now let's get inside the payment service. So go one directory back, then payment service and hit enter. Now let's run maven compile zip docker build. Okay, so it has started the process. You can see till that. Let me close this location service, minimize this, and now after the payment service, let's get into the pricing service. Open this pom.xml. Inside the plugins, let me provide the plugin. Okay, for pricing, guys, we'll give pricing instead of this airline. So let me remove this airline and give here pricing. Okay, image name is changed. Now let's load the maven changes and now let's open the terminal and you can see build is success for the payment service. So let's verify that the payment service image is generated or not. So it's generated, you can see. Now let's go to the IntelliJ IDEA. Let me close this payment service pom.xml and now let's go from this payment service directory to pricing service directory. So cd pricing service. I need to go one directory back first. Okay, now I'm inside pricing service. Now from this directory, I can run maven compile zip docker build. Okay, and processes start for the pricing service. So let me minimize this. And now let's go to the seed service pom.xml. Okay, for this guys, we need to provide the plugins of Google Jeep. Now let's give the name seat, GDS seat, Joe's YouTube GDS seat. Let's load the maven changes, open the terminal, and you can see build is success for the pricing service. So let's open Docker desktop and check. You can see image is generated for the pricing service. So now let's open the IntelliJ IDEA. Let me close this pricing service. Okay, now let's get inside this seed service. I will go one directory back, then get into the seed service. Now from this seed service directory, I can run maven compile zip docker build. Okay, and let's minimize. After the seed service, we have left only user service. Okay, so let's provide the plugins for user service pom.xml file as well. Now inside the user service, we need to provide YouTube GDS user. Okay, let's reload the maven changes. And now let me open the terminal. YouTube GDS user. Okay, no problem. Build is success for the seed service. So let me close the seed service, and once verify inside the Docker desktop that for seed service image is generated. Now from this terminal, I need to go inside the user service. User service. Now from this user service directory, I can run maven compile zip docker build. Okay, and let's wait. So guys, it's processing. Till that, let's do one thing. Create Docker images for cloud service as well, like service registry and API gateway. Okay. So let's open the pom.xml of API gateway. Inside the plugins, let me provide the plugin. And let's provide here image name GDS, then API gateway, API gateway. Okay, now let's open the terminal. Build is success for user service. So let me close that pom.xml and verify inside the Docker desktop that YouTube GDS Docker image is created for user service. Now let's go to our project. Now from this user service directory, I need to get inside the API gateway. Okay, so let's go one directory back and again go back. So from the user service, I came inside the services, and then again one directory back means I came inside the microservices. Now I need to go inside the cloud and then go to the API gateway, and there you go. Now I'm inside the API gateway directory. Now from here, I can run maven compile zip docker build. Okay, so it will take couple of seconds. Till that, let's provide this plugins, Google Zip plugins inside service registry. So let me open the service registry pom.xml file. This is the service registry. Inside plugins, let me provide the plugin, and let's provide the image name here. So YouTube GDS service, and let me provide registry. Okay. Now let's open the terminal, and build is success for the API gateway. So let's verify it inside the Docker desktop. You can see images generated for the API gateway as well. Now let's go to the IntelliJ idea from API gateway. Now let's get inside the service registry. So service registry, service registry. Okay, like this. So now I'm inside the service registry directory. From here I can run maven compile zip docker build. So let me hit the enter, and it will generate image for service registry as well. Let's wait for a couple of seconds, and let's check inside the Docker desktop. Okay, you can see build success. Now let's check inside Docker desktop. You can see image is generated for service registry. Great, guys. So we have generated images for all our microservices. That's it for this video. In the next video, we'll write Docker compose file. Okay, so let's meet into the next video. Alright guys, so far we have been running containers like this. One command, one container, right? But now, imagine our Joe's airline system. Inside it, we have multiple services like user service, booking service, payment service, database, Kafka, Redis, etc. 10 plus containers. So are you going to run all of them manually? No chance. So what's the solution? Here Docker Compose come into the picture. In simple word, Docker Compose lets you run multiple containers together using just one file and one command. Think of it like this. Earlier, a Docker run equal to running only one service. But now, Docker Compose equal to run the entire system. Okay, you just write everything in one file called dockercompose.yaml file. Inside that file, you will define all your service ports, environment variable, dependencies, etc. And then one command you will run docker compose up, and boom, your whole microservices system starts. Now if you want to stop them, you will run docker compose down. So in one line, Docker Compose is a tool to manage multiple container applications easily. And in real world microservices, this is not optional. Docker Compose is the essential in real world microservices. So now let's write Docker Compose file for our microservice project. Let me create inside this microservices we have all the services like cloud, common library, and services. Now here let me create one folder, Docker Compose. Okay, now let's open this Docker Compose with the IntelliJ IDEA. Okay, Now inside this, let me create a new file, docker compose.yaml. Now inside this YAML file, will write all the services. So let me write here services. Inside this services, let's start with the user service first. Okay, so let me write here micro or microservices, or just like services. Okay, and let's start with the user service. User service. Now let's provide the image. So for a user service, we have image. Let me open the Docker desktop. For a user service, we have Josh YouTube GDS user. Okay, let's use that. Josh YouTube GDS user, and version 1.0.0. Let me check the version as well. 1.0.0. Yeah, that's the version. Now let's go to the IntelliJ IDEA again. Then let's provide the container name. So container name is GDS. Let's start with the YouTube GDS user service. User service. Then let's provide the memory limit. That is nothing but 512 MB. Then let's provide the memory reservation. That is also 256 MB. Then CPUs. So CPUs, guys, I will provide 0.5 core, 0.5 core. Then let's provide the dependency. Depends on. Okay, so currently, guys, we haven't implemented the config server. So later our user service will be depends on the config server, because it will read the configuration from the config server. Then another dependency for this user service is service registry. Once the service registry start, only then user service would be start. And the last dependency is database. Okay, so let's write all the dependency one by one. Depends on, let me write here config server, config server. Then let me write here condition service healthy, and then let's provide service registry. Service registry, and let's provide the condition service healthy again. Then for user DB, and let's provide the condition service healthy. Okay, now we can provide the environment variable, guys. Okay, so let's provide the environment variable. After this depends on, we can provide environment. Inside the environment, we can provide the Spring Boot application name. So let me provide Spring application name. Actually, this application name is if already present inside the .yaml file, it will read from that. So let's not provide the application name, then config import, or we can provide, okay, so let's do one thing, let's provide the Spring application name. Okay, now let's provide the config import. Spring config import, and it's totally optional. Config server, and http :/ config server config server colon and 888 / okay, so first optional, then config server http config server 888. Great. Now let's provide the Spring data source URL. Okay, so JDBC MySQL user DB. So this user DB we haven't created yet, but we'll create this 3006 airline user, where this is the database name, then use SSL false and allow public key retrieval true. Okay, now let's provide the data source username and password. So let me provide the data source username and password. Spring data source username root, password is root. Now let's provide the data source driver class name. Okay, Spring data source driver class name com.mysql.jdbc driver. Now let me provide the Eureka client configuration. So Eureka client service URL default zone http service registry. Okay, instead of a local host we are using service registry, means service name. So this service also we haven't created, we'll create it on port 8761 and Eureka. Now let's provide the Java tool option. So this guy's a JVM memory limitation like 128 MB, then 384 MB, etc. Okay. Now guys, we can provide the network as well, and if we didn't provide any network, it will create the default network for this. Okay, so this is our user service, guys. Now you can see we have config server. So config server we currently don't have. Let me comment this service registry and config server this import as well. So let me comment this as well. All right. Now we need to first create the user DB. Okay, MySQL, then the service registry as well. Okay, so let's do one thing. First create the database. user database. Here let me comment now databases. So let's write the configuration for a database user db. Okay, inside the Docker container will run mysql. So let me provide the mysql image name, image mysql 8.0. so this image, guys, we are going to use. Then container name. So container name is userdb. Then memory limitation, there is nothing but 512 MB. Then memory reservation 256 MB. Then CPUs 0.5 core. Then let's export the ports as well. 127. So local host only for the debugging. Okay, let's expose here port 3302 and 3306. so this is the internal port and this is the expose port. Okay, internal port we have used here. Great. After the port we can provide the environment variable. Okay, so and let me create the environment variable mysql root password and database name. MySQL root password is root, a database name is airline user. So this airline user database we are using here. Okay, now we need to provide the health check. So let me provide the health check matrix. So in the health check we need to provide the test cmd mysql admin ping -h and localhost. Then interval is 10 second, timeout 10 second, retries 10 and start period is 10 second. Okay, so user db is now, guys, ready. Now go back to here and let's do one thing, create service registry as well. Okay, so we are using here service registry. All right, so let's write the service for service registry. After this, let me write here infrastructure, infra, okay, and here service registry. Let me provide the image Josh GDS service registry, and version is 1.0 1.0.0. Okay, and image name will be start from Josh / YouTube. Okay, and Josh / YouTube GDS service registry. This image we have here, you can see YouTube GDS service registry. Great. Service registry. Now after the image we need to provide the container image, container name, that is nothing but GDS Eureka server, GDS Eureka server. Then memory limit, memory reservation, and CPUs. Okay. Then let's provide depends on. So guys, this service registry depends on the config server. Let me copy this and let's uncomment this. But guys, currently we don't have the config server, so let me comment it again. This depends on. Then we need to provide the environment variable. So let's provide the environment variable as well. Okay, environment variable, let me give space a little bit. Spring config import. So let me minimize it for comment it for now, because currently we don't have config server. When we implement the config server, that time we'll uncomment this. Now Eureka service default zone. So HTTP service registry 8761 Eureka. So guys, we don't need to give this. Let me comment this as well. And in Java tool option, we'll provide JVM 120 MB, then 384 MB. Okay. Now instead of commenting this, let me remove it from the environment. Now guys, let's provide the health check matrix. So let me provide health check inside the service registry. Health check test cmd curl -f localhost 8761 actuator health. Interval 10 second, timeout 5 second, retrieve 10, and start period 15 second. Okay, so our service registry is also ready. Okay, now guys, similar we need to create for here you can see we have created for user service. So similar we need to create for booking service, airline service, payment service, seat service, etc. And same for the databases. Okay, so let's do one thing. Now create for airline core service. Okay, let me minimize this user service, and after this I'll create here for airline core service. So image name is Josh YouTube GDS airline 1.0.0. Then container name YouTube GDS airline core service. And here also let me give service registry container name YouTube GDS Eureka server. And here also let me give YouTube user DB. Or let's keep it user DB just. Okay. Now after the container name we have a memory limit, that is 512 MB, then memory reservation 256 MB, then CPUs 0.5 core. Then dependency we have config server. So for now let me comment config server. When we implement the config server, that time we'll uncomment this. Then service registry condition service health service healthy, then airline core DB. So this database is not created, but condition service healthy should be. Redis also not implemented, so let me comment this Redis as well. Then in environment variable we have Spring Boot application name, airline core service, Spring config import. Let me comment this as well. Okay, and then this is the data source URL, data source username, password. Then we have driver class name. Okay, and this is the Eureka client service URL default zone. So service registry. This service registry. Then we have Spring Data Redis host. Redis. Let me comment this Redis pod as well, because currently we are not using the Redis. Then Java dual option JVM memory 128 MB and 384 MB. Restart unless stopped. So let me remove this because we don't need that line, and this network also I don't need, so I will remove it. Okay, now similar guys, let's write for flight operations always. Let me minimize this airline core service, and let's write for flight operation service. Now in flight operation service, image name is Josh, YouTube, GDS flight. Oh, for flight guys, we missed the Docker image. Okay, no, we have the Docker image for flight as well. Okay, so we have created image for this, and we are using that image YouTube GDS flight 100. Then container name GDS flight operation service. Instead of, we'll use here YouTube GDS flight operation service. Memory limit 512 MB, memory reservation 256 MB. Then CPUs 0.5. Dependency, let me comment this config server, service registry condition, flight ops db condition, service healthy, and Redis also let me comment. Then Spring application name flight operation service, Spring config import, Spring data source URL, then data source username, password, and driver class, then service URL. Okay, service registry. Then Kafka bootstrap server, so Kafka 9092. And for Redis, let me comment this. For Kafka also, let me comment this. We'll comment it out when we implement the Kafka. And Java dual option JVM 128 MB, then 384 MB. Okay, now let me remove this. Now let's write for the location service. Okay, this is location service. Image name is Josh, YouTube GDS, location 1001. Then container name YouTube GDS location service. Memory limitation 512 MB. Then memory reservation 256 MB. CPUs 0.5. Dependency, let me comment this config server, condition service healthy, service registry service healthy, location db, will create this location db. Then for Redis, for now let me comment this. When we implement the Redis in our project, that time we'll uncomment this. In environments, Spring application name, then Spring config import, or let me comment this Spring data source. Here you can see we are using a location db. Will create this. Then we have Spring data source username, password, driver class, then service registry, Eureka client service URL, and this Redis host and Redis port. Let me comment this. Okay, then JVM memory. Now let me remove this. Okay, location service is done. Now let's write for the seed service. Okay, so let's write for seed service. Now inside seed service we have image, Josh, YouTube, GDS seed 1.0.0. Then container name, YouTube GDS seed service. Memory limit 512 MB. Memory reservation 256 MB. CPUs 0.5 core. Then we need to comment this config server dependency, service registry dependency, service healthy, seat DB service healthy, and Kafka. For now, let me comment. Inside environment, Spring Boot application name, seed service, Spring config import, let me comment. Then Spring data source URL, then Spring data source username, password, and data source driver class name. Then we have Eureka client service URL. Okay, and for now, let me comment this Kafka Bootstrap server. Okay, then let's create the pricing service. Okay, so let me provide the image, Josh, YouTube, GDS pricing, then container name, GDS pricing service. So YouTube GDS pricing service, memory limit, memory reservation, CPUs, and dependency. Let me comment the config server dependency. Then we have a service registry dependency and pricing DB. And let me comment the Redis dependency for now. Then we have environment variable like Spring application name. Then comment this config import, data source URL, data source username, data source password, data source driver class name, and Eureka client service URL. Then let me comment this Redis host and Redis port. That is great. Now let's write for the ancillary service. Okay, so now guys, you can see we have ancillary service. Image name is Josh, YouTube GDS ancillary 1.0.0. Container name, YouTube GDS ancillary service. Memory limit 512 MB. Memory reservation 256 MB. CPU 0.5 core. And depends on config server. So let me comment that. Service registry, service healthy, ancillary DB condition service healthy. Then in environment variable, we need to provide the application name, ancillary service, Spring config import. Let me comment this. Data source URL, then data source username, data source password, and data source driver class name. Then we need to provide Eureka client service URL as well, and JVM memory limitation. Great. Now let's create for the booking service. So let's create for the booking. Now you can see we have booking service. Image name is Josh, YouTube GDS booking 1.0.0. Then container name, YouTube GDS booking service. Memory limit, memory reservation, CPU. Let me comment the config server dependency. Then we have a service registry dependency, booking DB dependency. So we'll create this booking DB. Currently we don't have. Inside environment, you can see the application name, config import. So let me comment the config import, then data source URL, data source username, data source password, data source driver class name, and Eureka client service URL. Then we have Java tool options, JVM memory limitation. Now let's write for the payment service. Okay, so here you can see now we have payment service. Image is Josh JDS, Josh YouTube GDS payment 1.0.0. Container name GDS payment service YouTube. Memory limit, memory reservation, CPUs. Then dependency. So let me comment the config server dependency. Then service registry is, it should be service healthy. Then payment DB condition should be service healthy. Inside environment variable, we have application name, config import, let me comment. Then data source URL payment DB, this will create. Okay, and data source username, data source password, data source driver class, then Eureka client service URL, and for Kafka, let me comment this, and Java tool option, JVM memory limitation. Okay, great. So guys, now we have right configuration for all the services. Now let's write step by step for databases. Okay, so let me write for now airline core DB. Okay, so inside airline core DB, we are using here airline core DB, you can see. So let's create the database. Okay, airline core DB, image MySQL 80, container name airline DB, memory limitation, memory reservation, CPU core 0.5, and ports, let me provide 3003, and this is the internal port. Environment, so MySQL password root, then database airline core DB. So that DB we are using here, airline core DB. Okay, great. Then we have health check, so test CMD MySQL admin ping -h localhost interval 10-second timeout, retrieve restart periods 10-second. Okay, this is done. Now let's create for the flight operation DB. Now you can see we have flight operation DB. My image is same guys, MySQL 80, container name flight operation DB, then memory limit, and reservation CPU core. This time guys, port we have 3004. Okay, environment guys, root, password is root, database airline flight DB. So this we are using inside the flight database. So where is our flight operation? You can see here, flight operation DB we are using, airline flight DB. Okay, this is the database. Now health check is same as airline DB. Let me minimize this. After the flight operation DB, let's create for location DB. Okay, so location DB, image is same, container name is location DB, then memory limit, memory reservation, CPU, all these are same. Just port is now 3005. Earlier we have 3004. Then environment variable password is root, and airline location DB. So guys, this we are using inside the location service, airline location DB and location DB. Okay, and this is the health check test CMD. This is the same as above. Now let's minimize this location DB, and let me now write for the seat DB. After this, let me write for the setDB. So here you can see container name is setDB, memory limit, memory reservation, CPU, these are same. Port now this time we have 30011 for set. Sorry, 3311, not 0. Environment variable password is root and database is airline setDB. So let's go to the set service, airline setDB. Okay, after the set database, now let's create for pricing DB. Actually after the set database, okay, not inside the infra. Pricing DB, container name is pricing DB. Then this memory limit, CPU core are same. And for the port, we are using 3003307. Environment variable root. Then database name is airline pricing DB. Let me minimize the sheet. Open this pricing, and you can see airline pricing DB. And here we have pricing DB. Okay. So other thing will be same, guys. Health check and networks. Networks I can remove because currently we are not using any network. So let me minimize. Let me check for here as well. So, let me minimize setDB as well. Now let's write for the ancillary database. Okay, so let me create ancillary database. Image name, container name, ancillary DB, memory limit, memory reservation, and CPUs are same as above. Then ports, this time we'll use 3008. Environment password, environment variable, MySQL password is root, MySQL database name is airline ancillary DB. So this, let me show you here. We are using airline ancillary DB, and this ancillary DB is a service name which are using here. Okay, and other thing will be same, guys. Now let's write for the booking DB. Okay, this is booking DB, MySQL image, container name, memory limit, memory reservation, CPU core, and port. Let me provide 3309. Environment variable, password root, database, airline booking DB. And in health check is also same as above. So this airline booking DB. Let me show you which this where we are using airline booking DB. Okay. Now let me minimize this, and let's now write for the payment DB. Okay, container name is payment DB, then memory limit, reservation, CPU core, and port 3310. Then environment variable password root, database, airline payment DB, and this is the health check. Let me remove now network, we don't need it. Okay, so all the database is ready, guys. Airline payment DB, this we are using inside the payment service. Let me show you airline payment DB. Okay, and here we are using the service name payment DB. So this is the service name payment DB. Okay, great. Now guys, one more infrastructure service is left, that is nothing but API gateway. So let's write for API gateway as well. After this service registry, let me write here API gateway. Okay, and here we need to provide the image name, Josh, YouTube, GDS API gateway, and version is 1.0.0. Then let me provide the container name, YouTube GDS gateway. Then memory limit 512 MB. Then memory reservation 256 MB. And CPUs, let me provide 0.5 core. And let's provide the ports 5000 to 5000. Okay, now we need to provide the dependency. So let's provide the dependency config server. Let's copy the dependency and okay, let's provide the dependency and environment variables. Dependency config server dependency. So let me comment this config server dependency service registry. Then we have, and let me comment Redis as well. Then inside environment variable we have application name config server import. So let me comment this Eureka client service URL service registry 8761. Here you can see we have service registry. Okay, then let me comment the Redis host and Redis port. Then we have Java tool option, JVM memory. Okay, now guys, our Docker compose file is ready. Okay, so now guys, we can run this Docker compose file using Docker compose up command. Okay, so yeah, that's it for this video. Now let's meet in the next video, guys. Inside the next video, we'll run this Docker compose file and test it. Hey everyone, welcome back. In this video, we are going to understand what is the Kafka, what are the problems we are facing without Kafka, and how we can solve it with the help of Kafka. So let's understand it with one beautiful story. Imagine a city called Josh Airline City. In this city, we have multiple palaces like Payment Palace, Booking Palace, Seat Tower, Notification Tower, Flight Palace, etc. In this city, every building has one job. Payment Palace handle money, Booking Palace handle reservation, Seat Tower handle seat availability, Notification Tower send emails and SMS, and Flight Palace manage flight schedules. The city runs perfectly until the day a passenger pays for flight. The moment payment succeeds, the Payment Palace has a list of tasks, like he needs to tell Booking Palace, confirm this booking. Then he needs to tell Seat Tower, mark the seats as a taken. Then he needs to tell Notification Tower, send confirmation email. So, what does Payment Palace do? It picks up the phone and calls each building directly. He will call Booking Palace, waits and hold for the Booking Palace response. Then he will call Seat Towers. Again he needs to wait for Seat Towers response. Then he will call Notification Tower. Again he needs to wait and hold. It seems reasonable, right? But guess what? It will fail. Why it will fail? Imagine this. Someday, Seat Tower is closed. That could be any reason, like maintenance day or any other reason. But main point is, Seat Tower is closed. So what happened in that case? Payment Palace call seat tower and he will not get any answer from the seat tower because seat tower is closed. So Payment Palace will panic and he will say, I can't complete the payment. Seat tower didn't pick up. And then passenger will says, but I already paid. So problem will happen. The payment fails not because of money, but because of seat service that was temporary down. Okay. Now let's multiply this problem. So we have four main problems. Like first is tight coupling. Payment Palace must know the phone number of every building. Okay, without phone number he can't call to each service and tell him that payment is done. Second problem, failure spreads. If one building down, payment will fail. Third problem is slow response. If any buildings or services slow, then he will slow the entire flow of payment. Last problem, when new building get added, he must go into Payment Palace and add a new phone call. Okay, so Payment Palace is doing too much here, guys. It's calling people, it's waiting for replies, it's responsible for everything going smoothly. That is not its job. Its job is to handle money in the real production. So what is the solution? One day, the city builds a central post office called Kafka. And now, new rule will be applied. Payment service will not call anyone directly. Instead, he will drop a letter. Okay, let me change the slide first. So once the payment is success, he will drop the letter at the post office called Kafka. Whoever needs to know will pick it up. Now, when Payment Palace receive a successful payment, he will drop a letter at the post office, as I told you before. Letter will says payment completed, booking ID is this and amount is this. Then Payment Palace walks away because his job is done once he dropped the letter. Now behind the scene, from the post office where Payment Palace have dropped the letter, Booking Palace pick up the letter and he will confirm the payment. Then Seat Tower pick up the letter and mark seat as a taken. Then Notification Tower pick up the letter and send emails. Each building pick up the letter at their own space. If Seat Tower is closed today, no problem. The letter waits. When Seat Tower open tomorrow, it pick up the letter and process it. Nothing is lost, nothing fails. Okay, so now guys, we have three main concepts in Kafka. Let's understand it one by one. First concept is topic. Topic, you can assume topic as a mailbox. The post office has different mailboxes for different type of letters. Example, uh, post office have payment completed mailbox. It contains letters about successful payments. Then it has another mailbox, payment failed. It contains letters about failed payments. Then it has flight instance created mailbox. It contains letters about new flight schedule. Then flight confirm. It contains letters about confirm bookings. Each mailbox is called a topic. Now, second concept is producer. Producer you can assume as a letter writer. Who is the producer? The letter writer. The building that drops a letter into mailbox is called a producer. Payment palace drops letter into payment completed mailbox. Now, the third concept is consumer. So, who is the consumer? The letter reader. Here you can see booking palace is a consumer. Notification also consumer. Because they are seat tower also consumer. They are consuming they are reading the letters. The building that picks up the letter from the mailbox is called a consumer. Okay, these services are picks up letters from the mailbox. From the payment dot completed mailbox, booking palace picks up and reads. Now, multiple buildings can read from the same mailbox. Currently, you can see we have the two mailbox. One is payment failed, second is booking confirm, or okay, this booking confirm, and here we have payment completed. Let's see the another. Yeah, here guys you can see we have only one mailbox, means topic, payment completed. Now multiple buildings, means consumer, booking pallets, then notification tower, sheet towers, can consume the letter or read the letter from the topic. Multiple buildings can read from the same mailbox. This currently booking palace, set tower, and notification tower are doing. Now each buildings gets their own copy of the letter. So here is what actually happen in our system. When passenger pays, payment palace drop letter in the mailbox called payment dot completed with the booking details. Then post office, means Kafka, holds the letter. From that office, booking palace, seat tower, notification tower will read those letter and perform tasks accordingly. Like booking palace will reads letter and confirm the payment. Seat tower will reads the letter and update the seat availability status. Notification tower will read letter and send notification to the user or system. Okay, so payment palace finish its job in milliseconds. it doesn't it doesn't wait for everyone. If it doesn't know who reads the letter, it doesn't care. Now let's see the summary of our story. Kafka is a post office for microservices. Services drop letters and walks away. Other services pick them up when ready, independently, safely, without tight coupling. Okay, so that's the main concept of Kafka. Now let's meet in the next video. Finally guys, theory is done. Now it's time to actually run Kafka. The easiest way to run Kafka locally is Docker. No installation needed, no config files needed. You need just only one command. Okay, so let's create Docker compose YAML file. Inside this, we'll write configuration that runs Kafka inside Docker with resource limit and internal networking. So let's go to our IntelliJ, and inside this microservice directory, let me create one directory for Docker compose. Docker compose. Now inside this Docker compose, I will create one file, Docker compose .yaml. Okay, now let's write here services. Inside the service, let's write the Kafka service. Kafka. Okay, now let's provide the image detail. So guys, let's go to the Apache Kafka's website. Okay, here you can see this is the Apache Kafka website. Now let's click on the download, and here you will see the different images by version. Like this image has version 4.2.0, 4.1.2, 4.0.2. Okay, you can use whichever you like. So I will use this Docker image. Let me copy image from here, and inside IntelliJ, let me provide here image. Then container name, let me provide Kafka. Then we need to provide the memory limit. 1 means 1G means 1 GB. Then memory reservation 5112. Okay, why this is happen? M means MB. Then CPUs. Okay, 1 core CPU. Then we need to provide the environment. Environment, let's provide the Kafka node ID 1. Kafka node ID is 1. Then Kafka process role. Kafka, let me on the caps lock, Kafka process role. Roles. Then broker. Kafka process roles is broker and controller. Guys, let me do one thing. First write all the properties, then I will explain it one by one. Okay, now let me explain all this property one by one. Let's start with the image itself. So this is the image which we want to use. Then container name, memory limit is 1 GB. Okay, maximum memory Kafka can use is 1 GB. Then minimum reserved memory is 512 MB. CPUs, so limit CPU uses to 1 core. Then we have environment. Inside environment, Kafka node ID. So this is the unique ID for this Kafka node. And then we have Kafka process roles. So we have two roles, broker and controller. Broker will handle messages and controller will manage cluster. Then Kafka controller quorum waters. Okay, it defines controller quorum. Now, what should be the format of this defining this quorum? So format is, first we need to provide the node ID, then at the rate. So here you can see node ID is 1, then at the rate, and host name is Kafka, and the port is 9093. So here you can see controller port is this. Okay, Kafka listeners, here guys we have two port, 9092 and 9093. So 9092 is for client communication and 9093 is for controller communication. Then we have Kafka advertise listeners. So it's an internal host name used by other services. Then we have Kafka controller listener name. Kafka controller listener name, that is nothing but controller. It specifies which listener is used for controller. Then we have Kafka log directories. Okay, directory for Kafka logs and data. Then Kafka offset topic replication factor, that is nothing but 1. Replication factor for consumer offsets. After that we have Kafka transaction state log replication factor, that is also 1. Replication for transaction logs. Then we have Kafka transaction state log. Minimum ISR is 1. So minimum in sync replicas required is 1. Then Kafka auto created topics enable equal to we have provided true. So it will automatically create the topics if not present. We don't need to create manually. Now we have provided Kafka heap obs means JVM memory setting. Minimum memory is 256 MB and maximum memory is 1 GB. Okay, so environment is done. Now let's expose the port. So we'll expose port after the CPU. Let me provide ports and okay, let's format it. Now we need to provide ports 9092. So guys, now it will be accessible at localhost 9092. Okay, now let's open our Docker desktop. So this is our Docker desktop. Once you open the Docker desktop, your its engine is running. Now we can run this Docker compose file which we have created. So what you can do is you can open this Docker compose directory in command line, means PowerShell or command line cmd, or directly you can use this terminal as well of the IntelliJ. What I'm gonna do is I will open the this Docker compose in separate terminal. So let me open here. You can see I have opened this Docker compose in the separate terminal. Now I will start the service. So Docker compose. Inside this docker compose directory, guys, we have this file docker compose. Let me show you this. Okay, inside this we have this docker compose. So make sure you are using the exact name docker compose, then docker compose up, and -d means in detach mode. So it will run this docker compose file in detach mode. Let's hit the enter. Okay, so guys, it's pulling the images, but it got the error image Apache Kafka failed to resolve. Apache Kafka 4.2.0 not found. It says not found. Okay, so let me verify the image name. Okay, so guys, after 4.2.0 I have one extra dot, so I need to remove this. Okay, now let me restart this docker compose file, and you can see it's pulling the image from the docker hub. So if you don't have image in your local machine, then it will automatically pull the image from the docker hub. And if you want to download manually, you can pull the image manually as well. Okay, so guys, image is pulled. Then network docker compose default network created, and container Kafka also created, and it's running. So now let's go to docker desktop and verify that Kafka is running. You can see Kafka server is started. Okay, so guys, in this video we have set up Kafka in our local machine using the Docker. Now let's meet in the next video, and in the next video we'll actually use this Kafka in booking service, seat service, and payment service. So let's meet in the next video now. Finally guys, we have set up Kafka in our local machine. Now it's time to implement it in our project. So let's go to IntelliJ IDEA and start implementing it. We'll start with the payment service. So first let's add the dependency in pom.xml of payment service. Let's click on edit starter and search for Kafka. Now here we have Spring for Apache Kafka. Let's add this dependency and go to the bottom. Here you can see starter Kafka and Kafka test dependency we have. Now let's click on this load Maven changes. So dependency is added. Now next step is to configure address of the Kafka in application.yaml file of the payment service. So let's configure inside this Spring. We have Kafka, and bootstrap server we have localhost 9092. Okay, this is the address where Kafka is running, localhost 9092. Because we will run our Kafka in Docker. Okay, and Docker will expose this port 9092 that can be available using localhost 9092. So let's go to now package.com com.josh. Inside com.josh I have created one package config. Now inside this config package, let me create one Java class, Kafka producer config, Kafka producer config, and it's a Java class, guys. Okay, now we need to annotate with the configuration. Then Let's access the bootstrap server value here. How you can read that? First, let me define the string bootstrap server. Now, how you can read this from the application.yaml using @value. Okay, and it should be wrapped with the double code. Now here we need to write like spring.kafka.bootstrap server. We have localhost. Okay, now let's create one bin class here. Producer factory string object producer factory. Okay, now let's create one hash map. This is the hash map. Okay, let's import the map. Let's change the variable name config. Inside this config, we'll set the Kafka property like config dot put. First, let's provide the bootstrap server. Producer config dot bootstrap server. Then we need to provide the serializer class. So config.put key serialize config serializer class. Now we need to import the serializer. Okay, then we need to provide a value serializer class config. JSON serializer. JSON serializer. And let's return new here default Kafka producer factory. Let's provide here config. Okay, now let's annotate this class with the bin. And let's create here Kafka template string object Kafka template. Inside this, we need to return new Kafka template and produce factory. Now let's annotate this also with the bin annotation. Now let's understand this config file step by step. Okay, so start with this configuration, guys. We have annotated our class with the configuration annotation. Now this tells Spring, hey, this is the setup class, create bin from here. Okay, and in the second step, we are reading the value of bootstrap server from the application.yaml file. This is nothing but address of Kafka, where Kafka broker is running. Then we have a create class for produce factory. Now this is where we define how messages are created and sent. We have three main property: bootstrap server config, that means where to send the message. Then key serializer, it will convert key into the string. Then we have value serializer class config, it will convert Java object to the JSON. Okay, now guys, you can assume this method like packaging your parcel properly before shipping. Okay, And finally guys, we have Kafka template. This is the actual delivery guy. Whenever your app wants to send a message, it use Kafka template to deliver it to Kafka. Means with the help of this Kafka template will um, consume the event and produce the event. Okay, so let's now produce the event. So guys, when our payment is done, let's go to the payment service first. Payment service IMPL. Initiate payment. To do fetch the user details using fan client. Okay, so this will do it later. For now, we'll have the to do. Yeah, there you go. Inside the verification payment method, we have to do publish Kafka event. So guys, once the payment successful, then we'll produce the Kafka event here. Okay, so let's do one thing. Create method for producing event in a separate class. We can create one package, or we can directly here also write the logic, but it will mess up the things. So what we can do is, let's create one package inside this com.josh. Create package here, payment event producer. Actually, event package name is event. Inside this event, let me create one class, payment event producer. Payment event producer. Okay, so inside this producer will write the method to produce the event, and then directly we can call it here. So our code will be the structured code, state the structure, structured and well organized. Now here let's use Kafka template. So let's create the instance of it. Final Kafka template. And we need to provide string and object and Kafka template. Now let's annotate this class with the service and required as constructor. Now guys, to use the Kafka template, I guess we need to annotate our main class. Do we need to enable Kafka, or it will automatically handle? Okay, so let's not provide it for now. If we need, we'll later annotate our main class. But for now, let's create here method send payment completed event. Public, it will return void. What this method will do is just send payment completed event. Payment completed event with the payment object. Payment. Okay, now we need guys payment completed event class. So we don't have the class. Let me first provide here payment. Why I'm not able to write? Payment completed event class. Event equal to payment completed event dot builder will use here, guys. Builder dot build. Okay, now let's do one thing. Create a payment completed event. Let's create this event inside the common library. Inside common library, we have com.josh. Inside that, let's create one package called event. Inside this event, let me create the class name, payment completed event. And now, guys, we need to provide here fields like payment ID, booking ID, user ID, amount, transaction ID, provider payment ID, and pay date. Okay, so let's provide first. Let's annotate with the getter setter data, then builder, no action sector, all action sector, all action sector. Now let's provide all those fields like payment ID, booking ID, user ID, amount, transaction ID, provider payment ID, and pay date. Now let's go to here and okay, it has imported. It's not imported this class, but still it's not giving me the error. How it is possible? Okay, so now guys, let's set all the fields here. Like first we have the payment ID, payment.get ID, then booking ID, payment.get booking ID, payment.get booking ID. Then we have user ID, payment.get user ID. Then we have amount, payment.get amount, transaction ID, payment.get transaction ID, provider payment ID, payment.get provider payment ID, and finally pay date, payment.get pay date, payment.get pay date. That's all. Okay, now with the help of Kafka template, we can send the event. So Kafka template dot send, and we need to provide first a topic name. So payment completed topic name is, and send the event. So guys, if this topic is not exist in our Kafka, it will automatically create, because inside the Docker Compose file we have provided the configuration for auto created. Where is our Docker Compose? Yeah, there you go. Now let me show you that as well. You can see auto create topics I have enabled true. Okay, now we need to use this method send payment completed, and let's do one thing, create one payment failed method as well. So let me create payment failed event. Let's remove this. And create this event as well. Create one class inside the com.josh.event and inside the common library. Let's create this class. Okay, and we need to provide the fields like payment ID, booking ID, user ID, amount, transaction ID, field reason, and field 8. Okay, let's annotate with the data, builder, no action sector, and all action sector. Okay, now let's go to the method. Simple guys. First we have created a simple payment completed event class. Okay, set all the fields. Then we have just used Kafka template. Okay, sent. Then provide the topic name, payment completed, and in the second parameter provide the event. Same for the send payment failed, like Kafka template, send, topic name is this time payment failed, and event. Now let's go to the payment service IMPL. Here you can see we are using payment Kafka event. So let me send here. Okay. Payment, what is the payment event producer? This is the class name and method name is send payment completed. Let's create one instance, payment event producer payment. Okay, and now you can see automatically created the instance for payment event producer. Now let's use that. Producer dot send payment completed. Here I need to just provide the payment. That's all. Great. Now if it is failed, then we need to send the failed payment event. Let's send failed payment event. Publish payment success Kafka event and payment failed Kafka event. Okay, now let me remove this to do because we don't need the to do. Directly we can write this comment, publish payment failed Kafka event and publish payment success Kafka event. Okay, that is done. Now guys, let's do one thing. Here we are using the this dummy user. Okay, so instead of fetch user details using fan client, okay, so let me go to the user service and check for the controller. Actually user controller. Okay, here we have method get user by id, so let's use this method. Inside the payment, where is the payment? Yeah, payment service, we have a client or not. We don't have a client package. Let me create one new package client. Inside this, let me create a user client. User client, and it should be interface. Let's annotate with the rest. Sorry, fan client. Fan client. So we need to add a fan client dependency first. Let's add a fan client dependency. Open fan. Okay, and we need to enable in the main class. Enable fan clients. Fan client. Enable fan clients in main class. Now let's go to the user client. Annotate with the fan client. Provide the name and what should I give here? User service. User service name. So user service. User service. Okay, now let's use this method get user by id. Remove this and do it like this. This user ID will accept from the path variable. Let's provide API slash users. This is our full path, API slash user, then user ID. Okay, now let's load Maven changes since we have added dependency for frame client. Now let's go to payment service IMPL and fetch here actual user details using user client. Let me create a user client instance. So user client instance is created now. Now let's use the method get user by ID. Okay, request dot get user ID, and that's all. Now let me remove this to do word because we have implemented this fetch user details using frame client. Okay, this is done, guys. Payment has produced the message. Now as a next step, booking service, let me show you in our slide. Like a booking service, then seat service and notification service will consume that event. So where it is, okay, this is the Kafka. Payment service will drop letter here, means produce the event here. Then booking palace automatically will consume this. Notification service also will consume, and seat service also will consume that event. So now it's time to write a logic for consume. Let's start with the booking. Go to the booking. Inside the pom.xml, first we need to add the dependency for Kafka. Okay, once the dependency is added, we need to provide configuration in application.yaml file. Okay, so here guys, let's provide first the bootstrap server detail. Kafka bootstrap server detail, servers detail, that is nothing but local host 9092. If other fields we need, we'll provide it here. Now let's create the Kafka consumer config. Inside com.use, let me create new config package. Inside this config, I'll create a new Java class for Kafka consume config. Kafka consumer config. Kafka consumer config. Okay, let's annotate with the configuration. Then read here bootstrap server information using the value dollar curly braces. Let's import this value and use here kafka.bootstrap server. Then group ID as well. Okay, so guys, we need the group ID, and group ID details we haven't provided. Inside our application.yaml file. So let's do one thing, provide the group ID details as well first. Consumer, inside this consumer, let's provide the group ID. Booking service booking service group. Okay, now let's go to the consumer config and read that group ID as well. Private string group ID. Now let's read with the value. And provide here string.kafka. Instead of bootstrap, let me provide here group ID. Okay, that is great. Now let's create the consumer factory. Public consumer factory string object consumer factory class, and let's make it bin. Okay, let's create one map for storing the Kafka properties. Config equal to new hash map. Okay, we need to set here first bootstrap server. Config dot put consumer config. Consumer config dot bootstrap server config, and let's provide the bootstrap server detail. Then group ID. Okay, after the group ID, let's provide auto offset reset config. Config dot put consumer config dot auto offset reset config earliest. It means if offset is not present, then start from the top. Earliest. Okay, now let's provide the deserializer class. Config dot deserializer class. Okay, string deserializer. Now guys, let's provide error handling. So config dot put config consumer config dot value deserialize class config, and let's provide the error handling. Error handling deserializer class. Okay, so if any error occurred during the event consume or produce, it won't break the application. Instead, it just handle the error here. Now let's provide the value deserializer class. Config dot put this is for error handling. Value deserializer class. JSON deserializer class. Let's import this JSON deserializer class dot get name. Okay, now we can provide a trusted package as well. So config dot put, this is for security, and JSON deserializer dot JSON deserializer. So which JSON deserializer I'm using? From the JSON bind. JSON deserializer. Inside the Kafka, do we had a JSON serializer? JSON deserializer. Okay, so JSON deserializer is now deprecated. Let's use here a JSON deserializer. And here also we'll use JSON deserializer. JSON deserializer dot trusted packages. And here we need to give com.josh, then common library dot event. This is the package name, wherever all the event package event classes is lives. So common library, then com.josh, then we have event. Okay, inside this event we don't have this common library. Let me remove com.josh.event. Okay, com.josh.event. Inside this event classes lives. And okay, now let's return here default Kafka consumer factory. Okay, great. Now guys, let's create Kafka listener container factory class. So public concrete Kafka listener container factory. And method name is Kafka listener container factory. Kafka listener container factory. Concrete Kafka listener container factory string object factory, then new concrete Kafka listener container factory, and let's set here factory dot set consumer factory. So we have created this consumer factory. Okay, this consumer factory we need to set it here. Okay, now let's return this factory, return the factory, and let's annotate with the bin. Okay, now Kafka listener container factory is ready. Now with the help of this factory we can listen or consume the event. Okay, so now inside the booking service, let's create one package event. Now inside this event, let me create one class, Kafka consumer class. Kafka consumer. Actually, let's give the inside this event, let's create one class. And let's give a class name. It will consume. So which event, it will consume payment success event. Okay, let's create one okay, inside this let me create one more package called listener. Now inside this event I'll create one more package. First is listener, second is publisher. Okay, now inside this listener let me create one class, payment event listener. Payment event listener. So here we'll write the logic to listen the event. Okay, let's listener. Okay, now let me rename the file. We need to guys annotate this class with the service and required as constructor. Service and required as constructor. Now let's create one method, void handle payment completed event. So we have payment completed event class. Okay, yeah, now color base is created. Now guys we need to annotate with the Kafka listener and which topic he will listen. So payment completed, payment dot completed, and group id let's give booking service group, booking service group. Okay, so guys it will listen the payment completed topic which we are sending in payment. Where is the payment producer? Okay, let's go to the payment service. Inside payment service we have payment event producer. So here you can see we are sending payment complete event. Okay, that event we are listening here, and group id. So this group id we have provided inside the application.yaml file. Okay, this group id. Okay, and one more thing guys, this payment event producer is sending the payment completed event class. Okay, so that we are receiving here. Okay, great. Now as a next step I will fetch the booking. Let me import this booking equal to booking repository dot find by id. Let's provide the id. So guys inside event we have booking id, or else throw new exception, booking not found. If booking not found, let's add exception to the method. Okay, or guys let's do one thing. Instead of throwing the exception, because it will break our application, just return null. Okay, That is great. Now, if booking is not null, then we need to change the status of it. So booking dot set status, booking status dot confirm. Okay, once the payment is completed, we need to uh, update booking status from pending to confirmed. I said booking not equal to null. So if booking is null, let's return here. Return null. Okay, we can't do this like, so let me write here null, and if booking equal to null, then just return simple. Okay, well, now that warning goes. Now we can save the booking in our database with the updated status. And after this, guys, what we need to do is we need to set one more event from here. Once the booking get confirmed, we need to tell sit service that marks it as a reserved, because payment got success now. Okay. So let's do one thing. Here we need to fetch the flight instance using flight client. Let's it will return the flight instance response. Flight instance response equal to do we have flight client? Yes, inside this we have flight client. Use that to get flight client dot, I need to fetch the flight instance, get flight instance by id. So that method we don't have. Let's do one thing inside the client, flight client. Let's create that method. Go to the flight operation service. Inside the controller of flight instance, we have find by id, get flight instance by id. Yeah, let's use this method. Copy this, go to the flight client, provide here. Let me first provide the full path, api slash flight instance. Okay, and I don't need this, so let me remove this and provide this as well. Flight client dot get flight instance by id. And let's provide the flight instance id. So flight instance id is inside the event, actually not inside the event, but inside the booking. Booking dot get flight instance id. Yeah, here we have the flight instance id. Okay, now let's fetch here fare as well. Fare response We have pricing client dot get fare by id, booking dot get fare id. Okay, now let's provide the user DTO. User DTO equal to here we'll use the user client. Do we have a user client? No, let me create one. Inside this client, user client. Okay, and let's give here interface, annotate this class with the fan client, user service. Okay, and let's give the name here, name equal to user service. Now let's go to the user service controller and use this copy. Where is the user client I have created? User client, yeah, here. Now let's provide this method get user by id. Let me remove this. Now let's provide the full path plus ABI users. Okay, now let's go to the payment event listener, user client dot get user by id. So booking dot get user id. Inside the booking we have the user id. Okay, now guys, here we'll produce or publish the event. So publish event for sit service and notification service. Both will consume it. Guys, let's not make it too complicated. Let me remove this for now. Okay, for now just let's listen payment completed and payment failed. Okay, then we'll decide what we need to do for this. So now let me create one more method here, public void handle payment failed event, and guys, it will listen Kafka listener. It will listen topic payment failed failed. Okay, and let's provide here group id. Group id is booking service group. Booking service group. Booking service group like this. Okay, and here guys also will fetch the booking. Then we'll update the booking status. Set status. Now booking status will be cancelled because payment got failed. Let's save it in our repository. Booking repository dot save. That's all. Okay. Here we are handling payment failed, and here we are handling the payment completed. If payment completed, we need to update booking status from pending to confirm and save it into the database. That's it. If payment fail, then we need to cancel the status and save the booking in our database. That's all. Okay, now let's same implement for seed service as well. So let's go to the seed service inside com.josh. Let me create a new package first, not a class. So let me create the new package event. Inside this event, let me create one method for payment event listener. Payment event. Okay, inside this class, I will create one method for handle payment success. Okay, so we'll update here seat status, seat availability. Let me annotate with service class and required as constructor. Now let me create one method void, and method name is handle booking confirmed. Handle booking confirmed, and let's access here payment completed event. Let's annotate with the Kafka listener. So we need to add the Kafka dependency inside the pom.xml. Let me annotate, provide here Kafka, Apache Kafka. Now, guys, we need to provide application.yaml file configuration as well. So inside application.yaml, we need to provide bootstrap server address and group ID. Okay, so let's provide those details inside the seed service YAML file. Now here I will change the group ID. This is seed service group. Or booking, earlier booking service group, right? Okay, this time let's provide it seed service group. Let's load Maven changes, and annotated is Kafka listener. Let's provide here topic payment completed, and another detail we need to provide for group ID. So let's provide here group ID. Group ID seed service group. Now this group ID we need to provide in consumer factory as well. So let's create one config package inside the service seed service. Inside this I will write consumer class, Kafka consumer config. So guys, same consumer we can use of booking. Inside the booking we have Kafka consumer config. So let me copy this and provide that same inside seed service. Let me provide here, and bootstrap server group ID seed service group, then consumer factory bootstrap server config. All these are same, guys. We don't need to make any changes here. Okay, now let's go to the SID service listener, SID service payment listener, where it is. Inside the SID service, we have payment event listener, handle booking confirmed. Okay, now here, first guys will fetch the booking. So it will return booking response. Do we have the booking client? Booking client. Okay, we don't have booking client, so let me create one Java interface booking client, and let's annotate with the fan client, name equal to booking service. Now I want a method for get booking by ID. So let's go to the booking controller and grab that method get booking by ID. Go to booking client. Provide here full path API bookings. API bookings. Okay. Now let me remove this response entity thing. I don't need this. Now let's go to the booking client. Get booking by ID. Event dot get booking by ID. And we need to throw the exception. Let's do one thing. Remove this exception. Okay. Great. Now guys, what we'll do here is change the status of all the SIT instances. So first from this booking response, we need SIT instances. List of long ID of SIT instance IDs. And let me import this list equal to booking response dot get SIT instances. These are the list of SIT instances. Okay, no problem. So let's do one thing. Provide here instead of log SIT instance response. SIT instances. Now let's run a for loop for it. For SIT instance responses instances. And use here SIT instance service. And so let me create here SIT instance service first. Final SIT instance service instance. SIT instance service. Okay, let me remove this R. SIT instance service dot SIT instance service inside the, where is the SIT service? Yeah, inside SIT service we have a payment listener. Now SIT instance service dot okay, so let's go to the SIT instance service. sit instance. We have only one method, calculate, and we want here one more method. It will return updated sit instance response, and method name is update sit instance status. Sit instance status. Okay, and it will receive sit instance ID and the status. Long sit instance ID and status of sit instance. So sit availability status. Now let's implement this method. Go to the sit instance impl and implement this method. Okay, it's implemented. First we need to fetch it by ID. So it will return the sit instance repository. Okay, set sit instance status and update into the database and return sit instance mapper dot to response sit instance. Okay, now what if sit instance null here? We need to throw the exception, or just return without throwing exception, just return null, or just return. Okay, let's return null. Okay, now let's go to the payment event listener. Now sit instance service dot update sit instance. So provide here sit instance response dot get ID and sit availability book. Okay, two things we need to provide. First is sit instance ID and second parameter is availability status. Okay, so yeah guys, that's it for the sit instance payment event listener. Now let's see one by one guys. First let's go to the payment. Where is the payment producer? Let me close this, close all this. Okay, let's go to the first payment service. Inside payment service IMPL payment event producer. So guys, here we are producing two events. First is for payment completed, second is for payment failed. Inside the payment service we have a verify payment method. If payment got verified, then we are publishing payment completed event, else we are publishing the payment failed event. Now this both event we are consuming inside the booking. So let's go to the booking consumer event or listener. Okay, here you can see we are consuming that event payment completed and updating our booking status from pending to confirm if payment is completed. But what if payment is failed? Then we are cancel the booking status and saved into the database. Guys, if payment is failed, the process is stopped here. Now we don't need to do anything else. But if payment is completed, then we need to update seat status as well. So again, this payment completed will listen inside seat service as well. So let's go to seat service consumer here. Okay, we are listening payment completed, and the group ID is this. Now guys, we are updating here seat instance status, okay, from available to booked. And one more thing guys, we need to provide this seat service group in this Kafka consumer config, because currently we are using the we are using seat service group, and that's okay. Okay, great. So guys, now it's done for payment completed event. So that's it for this video. Now let's meet in the next video. Hey everyone, welcome back. In the previous video, we have implemented Kafka in payment service publish event, and booking service and seat service consume that event and accordingly perform the action. Now we'll implement Kafka in our flight service. So whenever flight instance get created, it will publish Kafka event. That event consumed by seat service, and it will create flight instance cabin and seat instances for the flight instance. Okay, so let's go to our IntelliJ idea and start implementing it. First, let me close all this tab. I don't need as of now. Now let's add first dependency of Kafka inside the flight operation service. So Kafka, let me checkbox it, click on OK, and reload Maven changes. And it will take couple of seconds, so let's wait till that. Okay, it's done now. Now let's go to the config. Inside this config file, we'll create Kafka producer config. Inside fconfig, we have REST template. Okay, so here let me create new Java class, Kafka producer config. Kafka producer config. And I have made a spell mistake, maybe producer. Okay, it should be like this. Now let me rename this file, and now inside the resource application.yaml, I need to provide bootstrap server address of Kafka. So let's provide here. Inside the Spring, we have Kafka. Inside this, we have bootstrap servers. Okay, and let me provide here localhost 9092. Okay, now we'll read this value inside Kafka producer config. So first let me create one private field string bootstrap server. Okay, and let's read those value using @value annotation. And let's provide here $. Spring.kafka.producer bootstrap server. Okay, now guys, we already implement this Kafka producer config in the payment service. So let me go to payment service and copy those. Okay, and now let's go to the flight operation service Kafka producer config and provide those. Okay, I guess one curly braces is missing, so let me add that, and it's fixed now. Great. Now let's go to the IMPL package of flight operation service. Inside service we have IMPL. Now guys, whenever flight instance get created, okay, flight instance, create flight instance, here we have this to do publish Kafka event for a service event so that it can consume this event and create set instances and flight instance cabin. Okay, and this flight instance created by the flight schedule. So whenever flight schedule get created, here you can see flight instance is get created, create flight instance. Okay, great. So now let's go to the flight create flight instance method, and okay, first we need to create the event, then this event guys will call here. Okay, so let me create one separate package, event. Inside this event, let's create one Java class, flight instance event producer. Okay, now let me create here Kafka template. Okay, and in the first parameter we need to provide the string. Second parameter, let's provide flight instance created event class. So flight instance created event Kafka template. Okay, so this Kafka template we have configured inside the flight operation service config. So where it is, yeah, here you can see. Now this Kafka template instance we are using inside the flight instance event producer. Now let's create first class for this. Create class inside josh.event, and it should be inside the common library. Okay, now here guys, we need to provide three fields: flight instance ID, aircraft ID, and flight ID. But first let's annotate with the getter setter data, then all action constructor, no action constructor, and builder. Okay, now let's provide three fields here: flight instance ID, aircraft ID, and flight ID. Okay, now add a constructor parameter. So let's add a constructor parameter required args constructor, and let's annotate with the service class. Okay, now let's add create here method send flat instance created. Send flat instance created, and provide here flat instance created event class. Kafka template dot send flat instance created. Okay, so I need to provide topic name flat instance created. Okay, this is the topic name we'll use when we consume it. Flat instance created. Great. Now let's go to the flat instance create method, and here we'll publish that event send flat instance created. Flat instance event producer dot set send flat instance created. Okay, and here we need to provide the event. So events are not created. First let's create the event class. Okay, flat instance created event, and let's create the event equal to flat instance created event dot builder dot build. Let's set the values here. Flat instance id, flat instance dot get id, aircraft id, flat instance actually we need to provide here flight dot get aircraft id, flight id, flight dot get id. Okay, so guys, now event is sent here. Now let's consume this event inside seed service. Let's open our seed service. Okay, this is our seed service, and inside this we have already consumer. And what is the group id? Let me check this group id inside the application.yaml seed service group. Okay, now let's consume this event. Let me create here one class flat instance event consumer, flat instance event consumer. And let's annotate with the service required constructor. And guys, we need here cabin class repository, seed service in repository, flat instance cabin repository, and seed instance repository. So we'll create instance of it later. First let me create the method here. Handle flat instance created. Handle flat instance created. Flat instance created event. What is the return type of it? Is void. Now let's annotate with the Kafka listener. and let's provide topics. Flight instance created. Flight instance created, and let's provide a group id. Sit service group. Sit service. Okay, this sit service group we have inside the Kafka consumer config of sit service. So here okay, group id, you can see this is the group id. It's reading value from the application.yaml file. So let's go to application.yaml, and here you can see the group id sit service group. Now let me remove this to do pod. Okay, let's go to flight instance event consumer, annotated with the transactional. Okay, now inside this, guys, we'll listen the event and create flight instance cabin and sit instances. Okay, so first let's fetch the cabin class by id. So id coming inside this event. Cabin classes equal to cabin class repository dot find by aircraft id. Okay, so it will return the list of cabin classes which are present inside the aircraft. Let's provide here event dot get aircraft id. Okay, once we have cabin classes, we'll look through it. But first, let me do one thing. Store here sit instances. Total sit instances. Total sit instances equal to 0. Cabin class and cabin class. Cabin classes. Okay. Now for each cabin class, guys, we'll create flight instance cabin and sit instances. So let's first get here sit instance. Sorry, sits. So sit. Let me import this sit. Now cabin class dot get sit map not equal to null. Then sit repository dot find by sitmap id. And let's provide here cabin class dot get sitmap dot get id. Okay, now cabin class, actually it's not cabin classes. Cabin class dot get sitmap dot get id. Okay, else will return the list empty list of. Okay, now inside this sit repository, let me create this method because currently we don't have. Let's go to the sit repository. Find by sitmap id. it will return seat map, and let's provide the ID. Sorry, find by seat map ID. So it will return list of seats. Okay, find by seat map ID, it will return the list of seats. Okay, now we have the list of seats. First, let's create the flight instance cabin. Flight instance cabin equal to flight instance cabin dot builder build. Event dot get flight instance ID cabin class. And let's provide the total seat. So seats dot size and book seats is 0 for now. Okay, now let's save this flight instance cabin in our database. Flight instance cabin saved. Flight instance cabin equal to seat instance or cabin repository. Flight instance cabin repository. Flight instance cabin repository dot save flight cabin. Okay, once the flight instance cabin saved in the database, now we'll create the seat instances. Let's create here list of seat instances. Guys, we have seats. Okay, so for each seats we'll create the instance. So let's use here seats.stream.map method here. Map through all the seat one by one. Seat instance dot builder build. Okay, okay, let me remove. Okay, for now let's skip this and I will remove it. Now let's set the values here, like flight ID, event dot get flight ID, flight instance ID, event dot get flight instance ID, flight instance cabin. Flight instance ID. Okay, this is of this map. Why it is here? Let me remove. Okay, now let's set I have set the flight ID, flight instance ID. Now flight instance cabin. Flight instance cabin. Saved flight instance cabin. Then let's save here seat status. Status is seat availability status is nothing but available. Okay, by default all the seat instances are available. Then let's make is available true, is book false, is available true. Okay, now let's set the premium supercharge. So guys, inside the create flight instance, actually so this let me think about this, guys. Guys, inside the flight instance cabin service IMPL, we have this method get premium supercharge. So what I will do is I will copy this method and will use here. So after this, okay, and now let me set here premium supercharge. I'll use here this get premium supercharge, and let's provide the seat type. So seat dot get seat type, then window charge. Let's provide the window charge 1000 and agile charge is 500, and it should be the double, so let me provide it like this. Also let me provide this 100 like this. Okay, now let me remove this and convert into the list. Okay guys, so now our sit instances is ready to saved in the database. Let's save into our database using sit instance repository dot save all seed instances, and total seed instances is plus equal to set instances dot size. Now we can print here like how many set instances are get created, but for now let's not do that, and let's understand this method one more time from the scratch. So guys, here we are listening flight instance created topic. Okay, this event we are publish when flight instance get created. So here you can see we are publishing the event flight instance event producer, and that event we are consuming. Where is the consumer class? Yeah, consuming here set service. This is the group ID. Okay, now so guys, in the first step we'll grab all the cabin glass which are present inside the aircraft. Okay, now for each cabin glass we'll create flight instance cabin. Okay, so that thing we have done here. Once the flight instance cabin save into the database, we'll create seat instances for each seat. Okay, then we'll save those seats into our database, and that's all. So now from now, whenever a flight instance get created, one Kafka event will be published, and seat service consume that. After consuming it, it will create flight instance cabin and set instances for each seat. Okay, so yeah guys, that's it for this video. Now let's meet in the next video and test it. Guys, finally we have implemented Kafka in our microservices. Now it's time to test it. So let's go to Postman and start testing all the APIs one by one. So in the first step guys, we need a system admin. But before this, what I'm gonna do is I will uh, go to the MySQL command line and drop a databases of, let me open the IntelliJ IDEA, and guys, I will drop database of seat and flight operation service for now, and also booking service. Okay, so let me go to the MySQL command line and so databases. From this, I will remove YouTube Airline Booking DB, YouTube Airline Payment DB, and Seat DB, and also Flight. So where is the flight? Yeah, this Flight DB. Okay, let me drop this database. Drop a database. Okay, let me write it like this. Drop database. Now flight DB, and let's drop here payment DB. Now let's drop the seat DB. Okay, and let's drop booking DB as well. Okay, great. Now let's go to the Postman, and first let's log in. Log in with the SAM credential. Okay, let's go to the login and send request. Actually our server is not running guys, so let me start all the microservices. First we have API gateway, then ancillary, service registry, ancillary service, booking service, flight operation service, location service, payment service, pricing service, seat service, and user service. Okay, so let's wait till it's starting all the services. And of course guys, booking and flight DB we need to create. So we need to create all those DB which we have dropped recently. So first we have dropped the airline flight DB. Okay, this is our airline flight DB. Let me create. Create database. Then let me create airline payment DB. Create database airline payment DB. Then let's create airline seat DB. Create database airline seat DB. And let's create now booking DB. And also we need to create the payment DB as well. Okay, payment DB is already created here. So guys, first we have create flight DB, then payment DB, seat DB, and booking DB. That's it. Now let's go to the our IntelliJ IDEA again and start those services again. Like first booking DB, booking service, then flight operation service, and finally seed service. Okay, now let's run here our service registry, which is running on 8761. Okay, and on the service registry you can see all the services like airline core service, ancillary service, API gateway, flight operation service, location service, pricing service, user service. And why it's giving me the error, let me check. Kafka listener and point registry. Okay. Guys, we are getting this error because we forgot to provide deserialize class inside consumer factory. So let's go to first booking consumer. Inside the main Java, we have config file. Inside config, we have Kafka consumer config. And okay, here you can see I have provided this serialize string deserialize, but I need here this one, like consumer config dot key deserializer class config. Then instead of a JSON deserializer, here I will use JSON deserializer. Okay. JSON deserializer. JSON. Actually, JSON. JSON deserializer. Okay, and these are same, so let me remove this. Now, okay. Now, guys, still our Kafka is not running. So now let's do one thing. First, start the Kafka. So inside this, we have Docker Compose file. Okay, now let me open that Docker Compose file with new terminal. And now here I will run the Docker Compose file. First, let me start the Docker engine by opening a Docker desktop app. So let's wait to open the Docker desktop app. Okay, so start the Docker engine. It's starting. Let's wait till that it's starting the Docker engine. And now here you can see engine is running. Now let me go to the container. Here we have this Docker Compose. So guys, earlier we have start the Kafka using Docker Compose. Now let me remove this and we'll run new container. Currently we don't have any container. Now let's go to the command line, Docker okay, Docker Compose. We need to write like this, Docker Compose up, and -d means in detach mode. Okay, now it's created and running. You can see here Kafka server is started. Now let's go to the IntelliJ IDEA and start the booking service again. So let's go to the booking service and restart it. Let's wait till it's starting. Okay, there you go. Booking is okay. Still it's giving us error. Let's structure it guys a little bit. Let me first minimize this and this Kafka consumer config. So let me first provide here error actual deserializer, actual deserializer. Then let me provide here error handling deserializer, error handling deserializer. Okay, so first actual deserializer and we have error handling deserializer. Okay, let me, and this is the trust package. Let me comment here as well. Trust package, so you got understand better. Now let's do one thing. Actual deserializer. So first let me provide instead of actual deserializer, let me give here error handling deserializer, and actual I will keep after that actual deserializer. Okay, now here key deserializer class config and error, we need to provide here error handling deserializer, error handling deserializer. And let me minimize this. Okay, now after that value deserializer class config and error handling deserializer class. Error handling deserializer class. Now let's use here error handling deserializer dot error handling deserializer dot key deserializer class, and it should be string deserializer dot class dot get name. String deserializer dot class dot get name. Then let's use here Jackson deserializer dot class dot get name. Okay, great. Now let me start the booking service. Okay, so let's restart it now. This time I hope I will not get any kind of error because we have fixed all the things, and let's wait what it gives. I guess it is not able to connect with Kafka, so that's why it's giving me this internal class error. Okay, so let me check which. Okay, I have given the local host 9092, and now let me check the port of desktop as well. It is 9092. Okay, so let's minimize it a little bit. Why I'm getting this error? Okay, so it's giving the exception consumer breakpoint. Let's do one thing, guys. It's saying Kafka is not work. Kafka will not work. Means inside the Docker Compose, instead of this Kafka advertise the listener. So here instead of Kafka, I need to use localhost. Okay, and now let me delete this container and rerun it again. Okay, let's go to the terminal and start the container again. Docker compose -d, Docker compose of -d. Okay, and now you can see Docker compose is running. Means Docker is running. Now let's go to the IntelliJ IDEA. And restart the booking service. Okay, it will take some time to restart. Let's wait till that, and let's see what happened. Okay, so booking service is started, and now guys it's not giving any error, and you can see booking service group a partition assigned. That means it's connected to the Kafka. Okay, great. Now let's go to the booking service consumer class, and this configuration, guys, let me copy this configuration and will change this consumer configuration in seed service as well, because in seed service also we have the consumer configuration. So let me open the Kafka consumer config, and let's remove this and let's paste this. Okay, now let me organize the code. See, error handling deserializer and actual deserializer we have provided, and remove the old serializer. Okay, now let me restart the seed service as well. Okay, then we'll restart payment service as well. First, let's wait for the seed service to restart fully. Consumer client. Okay, here also guys you can see seed service group partition assigned. That means it is also connected to the Kafka. Now let's rerun payment. Okay, payment is also started. Now let's go to the discovery client. And now let me restart this. You can see we have payment, booking and seed service as well. Now let's go to the IntelliJ IDEA. Let me close all this tab Now let's go to the Postman to check all the endpoints. First, let me log in. Copy this JWT token and go to the profile. Inside airline admin JWT, let me provide that and check the profile. Okay, profile is getting fine. Now, guys, I have all the steps for checking the endpoint. First, we need to create cities if it is not exist. So let me check if cities is exist or not. Inside the city, let me get all the city and port is let me use here 5000 API cities unauthorized. So let me provide the JWT token and send the request. Okay, so I have 2-3 cities, 1-2 IDs 1-2 52. Okay, that's great. Now next step, guys, after creating city, we need to create the airport. So let me check airport is exist or not. If not, we'll create airport as well. Get all the airports. Let me send the request and there you go. We have airport for Bombay, then Delhi. Yeah, 2 airport we have, one with the ID 1 and 2. Now let's see the next step. After this airport, in phase 2, step number 4, register and login as a airline. So let me check, do I have the airline? So we'll call here get airline by owner. Let's go to the airline. In airline service, get airline by owner. Okay, and yeah, of course we have this airline with the ID 1. Okay, now as a next step, after the airline is done. Now let's check for aircraft. Aircraft is there or not? Oh, where is the, yeah, there you go, aircraft service. Now let's get by airline. So airline ID is 1 and we'll provide the JWT token of airline admin. So yeah, we have 1 aircraft with the ID 1 and 2. Actually we have 2 aircraft. Okay, that is great. 1 and 2, let me open. Now let's go to the docs again. We have get all aircraft, then create cabin glass for the aircraft. Now let's check we have cabin glasses or not. Okay, here we have get cabin glass by aircraft ID. So now we need to provide the aircraft ID 1 and 2. Let me send the request. So first, don't have any cabin glass. Let me check with the second aircraft, and it also doesn't have any aircraft. And guys, the request should be 5000. Let me do it again. API cabin glass aircraft 2. So let's create the cabin glass for this. Go to the cabin glass, economy code description, aircraft ID 1, display order 3 is bookable true. And yeah, with this request data, let me send the request for creating new aircraft. We have created aircraft. Sorry, we have created cabin glass for aircraft ID 1. So now you can see we have economy cabin glass. Okay, now let's go to and check the next step. Create cabin glass. Okay, so we have cabin glass. Now create seat map for each cabin glass. Let's go to the seat map and get seat map by airline, find by cabin ID. So currently we have cabin ID 1. Let me send the request. And what if I give it 2, 3? Okay, so it's returning null because it doesn't have any seat map API. It should be 5000. Okay, so let's create now seat map for the cabin glass. Created cabin glass. This one. Create seat map. Let me give here 5000 API seat map. Name, total row, left side row, right seats per row, and cabin glass ID 1. And seat map is created. Okay. Now find by cabin glass cabin ID. Well, let me find the seat map now. You can see we have seat map with respected seat as well. Okay, now let's see the next step. After creating the seat map, seat is created automatically. Now we need to create flight for it. So let's create now flight. Go to the flight service. Create flight. Flight number is this. Aircraft ID. Let me provide 1. Departure airport ID 1 and arrival airport ID 2. So let me verify the airport ID, guys. Let's go to the airport. Get all airports. Here we have ID 1. Let me minimize this. And we have ID 2 for the airport. Delhi airport and Bombay airport. Okay, so let's now go to the flight. Create flight for airport. Departure airport 1 and arrival airport 2. And flight is created, guys. Now you can see this is the airline, this is the aircraft of the flight, and departure airport of the flight and arrival airport of the flight. Great. Now make sure, guys, inside the authorization you provide the airline admin JWT token. Okay, only then it will work. Now let's see the next step. After creating the flight, in step 10 we need to create flight schedule. Okay, so guys, when we create flight schedule, flight instance automatically created, and flight when flight instance get created, it will publish the Kafka event for creating flight instance cabin. Let me show you that flow for creating flight instance cabin and seat instances. Okay, so now let's create the flight schedule. Where is the schedule? There you go. Here we have flight schedule. Create flight schedule. Okay, we need to provide a flight. Let's get flight by airline. Let me send the request. And okay, flight ID is 1. Let's go to the flight schedule. Flight ID should be 1. Departure airport ID 1, arrival airport ID 2. Departure time, arrival time, start date. So now let me use here 1st April to 25th April. Okay. Recursion type Recurrence type is weekly, operation day Monday only. Now let me send the request, and I got error API flight schedules. Okay, so port should be 5000 guys. Let me send it now. Can't convert value of flight instance created event to class Apache Kafka common serialization string serializer. Okay, now let's do one thing. Go to the first IntelliJ IDEA. Inside the application.yaml file, okay, this is the booking service, right? Now let's go to the seat service YAML file, and inside the consumer we have group ID. After that, let me provide here key deserializer and value deserializer. Key deserializer, and let's give here org.apache.kafka.serialization dot string deserializer. Now let's provide the value deserializer. Org.spring framework kafka.support. Serializer. And let's use here injection. JSON deserializer. Deserializer. Okay, now let's rerun this seat service. We are creating seat map, right? Actually flight schedule, and okay, it's auto reload, so let's not restart the server because it's auto reload. Let me save this one more time, and now okay, here we are getting this error. So now let's do one thing, recreate this flight schedule. Let's try again, and again I'm getting this same error specified in value serializer. Wide operation service, bootstrap. Okay, let's do one thing, create seats, restart the seat server once because we have updated the YAML file of it. and I don't think inside the flight operation service. Let me once check inside the flight operation service. Flight operation service, Kafka producer, producer config, value serializer class config, Jackson JSON serializer class. Now Jackson JSON deserializer. Okay. Great. And now let's hit this endpoint again. Okay. Now let's check the producer. So we are producing event from the flight operation service. Inside the flight operation service, we have Kafka producer. And guys, we forgot to annotate this class with the configuration. So we need to annotate with the configuration. Okay, so I guess I have made a same mistake inside the consumer. Let me check. No, inside the consumer there is no any mistake. But okay, here I have made this mistake. And now let me check this in booking consumer as well. Okay, here also not. And one more, guys, we have consumer and sorry, producer inside the payment service. So let me check inside that as well. If we have made some mistake, I will fix this. Okay, here also there is no any kind of mistake. Now let's go to Postman and test this API again. And okay, it's taking time, and this time it's giving me different error. What it says, timestamp status. Okay, let's me check inside the console of this Kafka template. Okay, let's do one thing, restart it, flight operation service, and we'll check what is the error that could not be found. Okay, so problem is inside the Kafka producer of flight operation service. Flight operation service, Kafka producer. And here, guys, instead of object, we need to provide flight instance created event class. And let me provide here as well, flight instance created event. And one more thing, guys, inside the payment also we are producing the event. So now let's do same changes inside the payment as well. Here, guys, we are publishing payment here we are publishing which, let me check inside the event, which class we are publishing, payment class. Okay, so inside the payment, let's keep object because it's not giving any error. Now let's go to the flight operation service and restart it. And it's running on 5011. Okay, no problem. Now let's go to the Postman and hit this endpoint. Again, I'm getting this error. Let me check the port number. API flight schedule. Where I'm getting this error. Let me check inside the API gateway. It says unable to find instance for flight operation service. So okay, it will take a couple of seconds. Let me refresh the Eureka dashboard, and here you can see we have flight operation service. Now let's send the request, and there you go, guys. Now flight schedule is created successfully. Okay, so once the flight schedule get created, flight instances will create for it, and uh, it will flight instances will created, and it will publish a Kafka event. This Kafka event consumed by seed service, and a flight instance cabin and seed instances also will be created. Now let's check those. So let's go to set instance. Where we have set instance, flight instance cabin. First let's check if we have a flight instance cabin. Flight ID 1. Okay, get schedule, get flight cabin by flight ID. Okay, and we have flight ID 1. Let me use here 5000 API flight instance cabin. Flight instance. Flight instances. Let me check first the flight instances. So where is the flight instance? Okay. Now get flight instance by flight ID. API flight instance, flight ID is 1 and page 1. So let me send the request. It says no static resource API, flight instances by flight ID. Okay, so what is the, we have get by airline ID as well. So let me send request here. Inside the authorization, let me provide the bearer token, and header, let me remove this. Is it 5000? Okay, and we have couple of flight instances with ID 1, ID 2, ID 3, etc. So now let's get flight instance by ID as well. 1, and there you go. We have this. Okay, now what we need to do is we need to get the flight instance cabin if it is created. Flight instance cabin, get flight cabin by flight ID. So API flight instance cabins, flight instance ID is 1. Let me send the request. If I give 2, and okay, it's not giving me any flight instance cabin. So let me verify the endpoint for it. It is inside the flight operation. Now let's go to the flight instance service, get flight instance by ID, flight instance cabin actually we have. So flight instance cabin. Flight instance cabin we have inside the seat service. So let's go to the flight instance cabin service. Get flight instance by ID, get flight instance cabin, get by flight instance ID, and get by flight instance ID and cabin class ID. Okay, so this by flight instance ID. Let's check the controller, flight instance cabin controller. API flight instance cabin, flight instance and flight instance ID. Get by flight instance ID. Guys, now we need to debug it's listening or not. So let's go to the flight instance event consumer. Okay, and here I will shout flight instance created, and let me get the flight ID from this flight instance ID. Flight instance cabin. Okay, and let's print here flight instance ID as well. Event.get flight instance ID. Okay, now let's restart the application. So we have made these changes inside the seat service, and it's auto reload. Let's do one thing, create another schedule. So let's go to the flight schedule, and arrival airport ID, departure airport ID. This time let me change the time from 16 to, let's use this time 14. Let's send the request. There you go. Schedule is created. Now let me check. Flight instance created 10, enable, and 12. So guys, it's getting printed. Okay, let me check one. Okay, 1 and 11. Okay, great. So this is working fine. Now cabin glass, does it have the cabin glass? I don't think so. That's why I think it's giving this flight IT1, and we are fetching cabin glass by the aircraft ID, which is inside event. Okay, now let me give this and print here aircraft ID as well. Now let me print here cabin class size. So cabin class dot size. Okay, and yeah, now let me restart the server. Okay, all the reload all the changes. And now let's go to the postman. Oh, why it's taking too much time? Okay, I don't think now it has anything to reload. So let me create another schedule this time. 17 to 14:15 and let's send request. Okay, it's created. Now let me check the log. Cabin class is ID1. Okay, its ID is also coming, so this is also working. Flight instance cabin, so why it's not creating? Let me check. Now let's go to the flight instance cabin. Flight instance cabin, get flight cabin by flight ID. Let me provide here one flight instance cabin, flight instance, and one. Flight instance 13, 14, 15. So let me check for 13. Okay, so guys, inside the flight instance 13 we have the flight cabin. Okay, and inside the flight cabin you can see flight instance, seat instance as well. Okay, so this is also working fine, guys. Earlier my mistake, I was checking a wrong seat instance, but now it's working fine. Okay, great. Now this API is working fine, guys. Okay, so that means, guys, our Kafka is being checked, okay, for sit instance created event. It is working fine. Now that's it for this video. Let's meet in the next video now. Hey everyone, welcome back. In this video we'll test Kafka for booking flow. So first let's start all our microservices. Let me click on this run button and it will start all the services one by one. So let's wait couple of seconds. Okay, and yeah, it's running. Service registry is up and running. So let me go to the browser and close this. Inside the Eureka Discovery client, guys, you can see currently there is 3 instances are registered. Let me refresh it, and now 3 and 4 more, 7 is registered, and now I guess all the instances are registered. 1 2 3 4 5 6 7 8 9 and 10. Okay, all the instances are registered successfully. Now let's start the Kafka. Okay, let me minimize this and to start the Kafka, guys, we have Docker Compose file. So let me open the terminal. Go to Docker Compose. Docker Compose. Okay, from this Docker Compose, I will run command Docker Compose up in detach mode, and make sure, guys, your Docker desktop is opened. Okay, Docker engine should be in running state. So now let me hit the enter, and container is created for Kafka. Let's go to the Docker desktop and verify that. Go to inside Docker Compose, and you can see Kafka is working fine. Okay, great. Now let me minimize this and minimize this terminal as well. So guys, for a testing booking flow, I will test. So in first step, guys, I will create one booking. Okay, I will hit the booking API. Then when I create the booking, it will return me the payment link, and I will make payment using that link. So let me write here, make payment. Then this once I make the payment, it will give me the payment ID, reserve pay payment ID. Now using that payment ID, I will verify the payment. Verify payment. Okay, once I will verify the payment, Kafka will publish the event, and that event consumed by booking service, and booking service update the booking status. Update booking status. Okay, so let's go to the Postman, and first let's create the booking. So guys, let me do one thing, create new account. Okay, so here I have given the full name, email, password, username, and role. Let me send the request. Okay, now let's copy this JWT token. Go to the profile, and here let me give JWT only, and inside this let me provide the RAM's JWT token, and it has given me the RAM user information. Now to create a new booking, let me open the booking service, create booking. I need the flight ID, flight instance ID. So let me check available flight in my database. Let's go to the flight service, set service, schedule flight instance. Where is the flight? Yeah, there you go. Here we have the flight. Now let's get all flight by airline. So what I need to do is let's get by the ID. Okay, static resource API flight, so one is not found. Okay, let's do one thing. I need to log in again, guys, for airline admin. So let me log in for the airline admin, and copy the JWT token. Now let's go to the get all flight by airline. Now here let me provide the airline admin JWT token, fetch all the available flights of the airline. Okay, so I have ID 1. Okay, so let's use inside the booking, inside the first booking, let me give flight ID 1. Now flight instance ID 1. Let me give the flight instance ID 1. Okay, I need to get flight instance by flight ID or get by airline ID we have. Okay, so let me use here admin JWT and fetch all the instances. Instance ID is also 1. So let's go to create booking. Instance ID is 1, cabin class economy, fare ID. Let me check if it has any fare. Where is the fare pricing or fare service? There you go. Now get fare by cabin class ID. Flight 1 cabin class 1, and let me give here admin JWT. Let's send the request, and okay, so ID is 1, flight ID is 1, so it has the fare ID. So let's use this fare ID for booking. Create booking, fare ID is 1. Now this is the passenger detail, then contact information and ancillary ID, guys. I will give empty, and meal IDs also I will give the empty area. Now let's go to authorization, and here I will give just a JWT token. This is the RAM's JWT token. That means RAM wants to book this flight. Let's go to booking and send the request. Okay, it will take couple of seconds to create a new payment link for us, and there you go. We have this checkout URL, so let's click on that and make a payment. So it's loading. Let's wait. Now let me give the mobile number, then let's give card. I have this dummy card. Now let's continue. Maybe later sending OTP. So OTP I will give. Bank verification needed. Let's continue, and let's click on the success, and now it will redirect me to the payment success link. Okay, it's redirecting. Let's wait till that, and there you go, it has redirect me. Now guys, here you can see we have RazorPay payment ID. So this payment ID I need, or let me copy this payment ID, and now let me open the notepad. Okay, and provide here this payment ID. Now we'll hit the payment verify URL API. So let's go to the payment service, and we have payment controller, and this is the verify. Where is it? Yeah, API payments are verify inside the request body. We need to provide this details. So let's go to the IMPL, like a RazorPay payment ID. Okay, so let's do one thing. Create here one request inside the payment. Do we have the payment directory? Yeah, there you go. Inside this, let me create one request for verify payment. Verify payment. Okay, and now let's give localhost API payment and verify. Method is post method, and authorization, let me give the bearer token JWT, and inside the body row let's give here RazorPay Where is it? Razor Pay payment ID. So let me copy this field. Let's go to the postman and provide it here. Payment Razor Pay payment ID I need to provide. So let me copy this and this is the Razor Pay payment ID. Now let's hit the enter and there you go guys. It has return gateway. So this is the payment object. Okay, and booking ID is 1 guys. You can see status is success. So now let's fetch booking by the ID. Let's go to the bookings where we have the booking directory. There you go. Now get booking by flight ID and get by airline ID, user booking history. Let me fetch this. Let's not provide user ID here, and instead of 5009 let's give 5000, and inside authorization let me provide the bearer token. Let's hit this API and why I'm getting empty. Let's do one thing guys. Fetch booking by ID, get by booking ID, and let's give the bookings. Then ID is 1, method is get. In authorization let me provide just a JWT token and let's hit the enter. And there you go guys. Booking is here, but I think it doesn't have the user. Okay, user ID is 1. Okay, so I guess the problem from the create booking inside the header, we have provided this X user ID. Okay, so that's the mistake guys. We don't need to provide the header, and in authorization we have provided the JWT token. Now problem is done. Now let's go to the booking ID, get booking by ID, and let's check the status. So currently guys status is pending. I don't know why status is pending, why it's not updated. Okay, so let's debug this guys. But wait, let's go to the booking verify. So payment verify, user ID is 1, booking ID is 1, and amount is this. Okay, now let's go to the IntelliJ IDEA and go to booking service. Inside the booking service we have event listener, payment event listener, payment completed, booking status is confirmed, and now let me do one thing. Out here event is coming or not. Receive payment completed event dot get booking ID. And one more thing, let me event dot get payment ID. Okay, now Let's reload the changes. Go to the terminal inside booking. Okay, booking is being updated. Now let's check once inside the Eureka dashboard. We have the booking service, okay, and payment service as well. Now let's go to the postman again, guys. Let's hit the verify endpoint, payment verify endpoint. So now let's go to the payment. Where is the payment? Booking fare, and here we have the payment. Let's send this request again. Okay, now let's go to the okay, why I'm not getting any console here, any log. So consumer client ID, consumer booking service, group 6, group ID booking service. Let me hit this again. Is it publishing event or not? Okay, so I'm not getting any event here. Now let's go to the payment and check, is it publishing the event or not? Payment service IMPL. Here we have the verify payment and payment event producer dot send payment completed event. Okay, let me shout here, payment verified successfully and published event. Let me give here send payment completed. Guys, let's do one thing. Let's print this inside the payment event producer. So where is the payment event producer? Inside the event we have payment event producer, and here you can see Kafka template sent payment completed. Let me print that here, payment verified successfully and publish event. Now let me give event dot get booking ID. Okay, and let's give the event dot get payment ID as well. Okay, now let me restart the booking service, actually payment service, because we have made changes inside the payment. And there you go, it's restarting and restarted. Okay, now let's go to the postman and hit this API again. Now let's go to the IntelliJ idea, and inside it let me check, it has payment verified successfully and publish event. You can see payment ID. Okay, so why it's giving the payment ID here? It should be the razor by payment ID. Okay, so guys, it's printing this payment verified successfully, but let me check inside booking I'm able to consume that event or not. Payment completed 0. Okay, inside of payment completed there is a 0 event, and from the payment it's being published. Let me do one thing, send it again. Now let's go to the IntelliJ ID again. You can see payment verify publish it's working, but why here I'm not getting any print message? So now let me go to the booking service event listener, payment, handle payment completed, payment dot completed, group ID is booking service group, and Kafka listener topics. Why this is happening inside the seed service? It's working, but Kafka is working for seed service but not working for this. Okay. Okay, guys. So problem is, let's go to the IntelliJ, and this is the payment event listener. So here we are listening payment dot completed topic, but we are producing, guys, something else like payment completed like this. So what we need to do is we need to fix this from a dash to dot, payment completed, and inside the listener payment completed. Okay, and here as well. So this is handle booking confirm, and this is handle payment completed inside the seed service. Okay, now guys, this is finished. Okay, and now this is fixed. Let's go to the postman and hit this endpoint again, and I'm getting the internal server error. So let me check inside the API gateway what it says. Failed connection, refuse get socket. Now let's go to the payment. It's working now. Let's do one thing. Let's try this API one more time, and there you go. This time I'm getting this response. Now guys, let's go to the IntelliJ IDEA and check if we are getting the. Okay guys, so you can see now it's listening. Now it's listening the Kafka event. So guys, this time it must change the booking status. So let me check now. Currently we have pending, and let's fetch it again, and there you go guys, status is confirmed. So that means Kafka is working for booking flow as well. So yeah guys, that's it for this video. Now let's meet in the next video.